today's lesson, solving problem in waves 1. Here I have the questions which I would like to take you through. The first question, it is written, a water wave traveled 12 meters in 4 seconds. If the frequency of the wave is 2 hertz, calculate A, the speed of the wave, B, the wavelength of the wave. So here we have solution. What we have in our question here is distance, which is 12. So 1, so we have distance, which is 12 meters. Then we have time, seconds. Time, 4 seconds. So part A, we are being asked to determine the speed of the wave. Speed of the wave. So speed generally is just given by the distance covered, then out of or divided by time taken. So I want to find the speed of the wave. I will have the distance covered, then divide it by time taken. This gives us distance is 12 meters, then time is 4 seconds. So if I take 12 divided by 4, it will give me 3 meters per second. This is the speed of the wave. This is the speed of the wave. So by listing these parameters, I've realized I've forgotten to list this frequency. So frequency, I've also been given frequency F is 2 hertz. Now part B, they are asking us to determine the wavelength of a wave. But generally from the relationship between wavelength, speed and frequency, we always say that speed is given by frequency then times lambda. Here V represents speed, F is frequency, and lambda is wavelength. So we are being asked to calculate wavelength, which is lambda. Now from my formula here, it simply means that if I want to get wavelength, then I divide both sides by F, frequency. So my wavelength lambda is equal to speed, then divided by frequency. Now we have speed. My speed is here. Then my frequency is here, which is 2. So I substitute in my equation. So this one gives me speed, which is 3 meters per second, then divided by frequency, which is 2 hertz. So this one, it will give me 1.5 meters. Remember, the units of measurement of wavelength, it is measured in meters. So that is why it has given me that one. This is the working for question 1. Now for question 2, we have the diagram. The figure below shows a displacement time graph for a progressive wave. So we have here a graph, displacement against time. So we have negative 10, then we have 10, then we have 10, 20, 30. Time is expressed in second, displacement is expressed in in meters. So the first part, we are being asked to state the amplitude of the wave. So this is question 2. Then Roman 1. When you are discussing these characteristics of a wave, we said that amplitude is the maximum displacement of a wave from the mean position. So if it is the maximum displacement, then this one, it represents our mean position is the x-axis. So maximum displacement, it can be upward or downward. Now from our diagram here, or from the graph, the maximum displacement this is amplitude, is 10 meters. Maximum displacement from the mean position. This is my mean position, and remember this equation, if I have it like this, so this is the maximum displacement expressed in meters. Now this one represents displacement is a vector quantity. It can be negative or positive, but we shall consider that one of positive. So from the graph, our displacement or amplitude is 10 meters. Then Roman 2, we are being asked to determine the frequency of a wave. The frequency. When you are discussing these characteristics, we said that frequency is the number of complete oscillations made by a particle in 1 second. From this diagram, when I want to make one complete oscillation for this wave, then I must have a crest and a trough. This is a crest, then this is a trough. Then you realize that this is a half of the trough. Now, from the diagram, this simply means that a complete wave, it will end at this point where time is 20 seconds. Because this is a quarter, when I add another quarter, then I have a half. This is a complete one. So meaning that a quarter of this plus a quarter of this, it will make this one to be a complete oscillation. So we always say that frequency, number of complete oscillation made by a particle within 1 second. Now, within 1 second. Now, our key term here is 1 second. So, I may say that this is the time. One complete oscillation, one oscillation is given by 20 seconds. So, what about 1 second? That is my now frequency. What about 1 second? Now from there, I cross multiply. I have 1 times 1, then divide by 20. This is giving me 1 over 20. In terms of decimal places, I may have 1 divided by 20, which is equal to 0.05. 0.0, that is frequency hertz. Then for Roman 3, determine the period of the wave. Roman 3. Period T, we said this one, the relationship between period and frequency is that T is equals to 1 over F. 1 over F. This F represents frequency. And I have calculated, I have here frequency. Meaning that if I want to calculate period, then I just substitute in the value of f. That is 1 over 0.05. So if I substitute in, I have 1 divided by 0.05. It gives me 20 seconds. That is the period. Then Roman 4, given that the velocity of a wave is 200 meters per second, determine its wavelength. I have said from the first question, the relationship between wavelength, speed, and frequency is that V is given by frequency, then multiply by lambda. This lambda is wavelength. So we are being asked to determine that wavelength. This means that my lambda is equals to speed over frequency. Speed over frequency. Remember, we have our speed, it is 200. Then our frequency, it is here, 0.05. So we just substitute in. We have our speed 200. This 200 divided by 0.05. So 200 divided by, that is 200 divided by 0.05. 0.05, it gives me 4,000 meters. It is giving me 4,000 meters. So this is the calculation or the solution for question 2. The amplitude is 10. We have frequency is 0.05. Period is 20. Then our wavelength is 400 meters. Now let us move to question 3. Move to question 3. For question 3, we have also been given this question 3. We have frequency f 3 times 10 raised to 6 hertz. Then we have our speed v equals to 3 times 10 raised to 8 meters per second. So we are being asked to determine the wavelength. From our previous questions, we have been able to simplify these wavelengths. And we have said that wavelength is just equals to speed then divided by frequency. Meaning that I just substitute in, we have speed 3 times 10 raised to 8 meters per second, then divided by 3 times 10 raised to 6. This is hertz. So if I divide this, it will give me 100 wavelength, which is meters. So this is the working for question 3. Working for question 3, the solution for the first 3 questions. So I would like to give you an assignment that you can try when you are at home. So these are the 3 questions that I would like you to try, to attempt. The first question, a rope is displaced at a frequency of 3 hertz. if the distance between the two successive crests of the wave train is 0.8 meters, calculate the speed along the rope. Question 2. The figure below illustrates parts of the displacement time graph of a wave traveling across water at a particular place with a velocity of 2 meters per second. Calculate the wave's amplitude, B, frequency, C, wavelength. So this is the diagram. Then C, that is question 3, distinguish between longitudinal and transverse wave. These are the questions that I would like you to try, not just trying but attempt, and you'll realize that they are very simple. That marks the end of our lesson of today. We shall meet tomorrow. God bless you and bye-bye. Today, we are still solving problems in waves 1, and I had given you an assignment yesterday that you are supposed to have done. Let me hope you have done, and I'm going to go through them. Now, I had left here 3 questions. The first question says a rope is displaced at a frequency of 3 hertz. If the distance between two successive crests of the wave train is 0.8, calculate the speed of the rope. Now, when you are discussing these characteristics of a wave, we defined the term wavelength. We said wavelength is the distance between two successive crests or troughs when a wave is under train. So from this question, it is clearly indicating that the wavelength is 0.8 because it's the distance between two successive crests. So solution for question 1. We have been given the frequency of a wave, frequency f3 hertz. Then we have also wavelength, lambda, which is 0.8 meters. So they are asking us to calculate the speed of along the rope. So in the lesson we said, the last lesson, that this speed is given by frequency, then multiply by lambda or wavelength. We have frequency, then we have our wavelength. So we just substitute in our formula. So you have 3 times 0.8. This gives us 2.4 meters per second. So this is the speed of that rope or of a wave along the rope. This is the solution for question 1. Now for question 2, the question says, the figure below illustrates parts of the displacement time graph of a wave traveling across water at a particular place with a velocity of 2 meters per second. Calculate the wave's amplitude, frequency, and wavelength. This is the diagram. So question 2, that is A. They are asking us to determine the amplitude of a wave. And from the definition, amplitude is the maximum displacement of a wave from the mean position. From my diagram, the x-axis, the time axis, the x-axis with the time axis, this is my mean position. So the maximum displacement of this wave, it becomes 0.4. Now I can say from the graph, the maximum displacement that is A, of a wave is 0.4 centimeters. Remember, this displacement is in centimeters. So this is 0.4 centimeters. Then part B, that is for frequency. We want to determine the frequency of this wave. Now, from the relationship between frequency and period, we said that frequency is given by 1 over t. But we don't have this t. We can calculate using this diagram. Now, from the graph, period t, this is the time taken by a wave to complete one oscillation. So an oscillation is made up of two halves. So meaning that time taken to complete one oscillation from the diagram, this is the first half, this is the second half. So if I add the two halves, they will give me one oscillation. Now, meaning that my period from this diagram, time taken to complete one oscillation, then is equivalent to 0.2. So this means that my period t is equal to 0.2 seconds. Now, when I want to find my frequency, so I substitute my formula. So my f is equivalent to 1 over 2, which is equals to 1 over 0.2. 1. So we take, that is 1 divided by 0.2. It is giving me 5 hertz. That is part B. Then for part C, the wavelength. Now, the formula relating wavelength, frequency, and speed, we know it. That is V is given by frequency, then times wavelength. This is wavelength, this is frequency, this is speed. Meaning that if I want to get wavelengths, then I can divide both sides by F. I have V over frequency. From my calculations here, I have frequency. Then speed, that is V, velocity. We have been given it is 2 meters per second. It is here. So we have speed, we have then frequency. So we just substitute in our equation. So this one gives us 2 over 5. 2 over 5, which is equals to 0.4 meters. So this is our lambda. Lambda is wavelength. So we have calculated the wavelength, we have our frequency, then this is our maximum displacement, that is amplitude. So we have our amplitude, then we have our frequency, it is here, then we have our wavelength, which is here. So this is solution for question 2. Let us move to the last question, it is question 3. Question 3. Question 3. Distinguish between longitudinal and transverse wave. So we can as well have, we can tabulate it. We can have something like a table, so that the first column we have transverse wave, then the second column we have longitudinal. So for transverse wave, we have two differences between longitudinal and transverse wave. For a transverse wave, the vibration of particle and is always perpendicular to the wave motion. So for transverse wave, if it is the first difference, is that the vibration of particle is perpendicular to the wave motion. While for longitudinal, sorry, here it is longitudinal, the vibration of particles is parallel to the wave motion. That is the first difference. This is the first difference. The second difference, we always say that transverse wave, it travels in a series of crests and troughs. While for longitudinal, this one, it travels in a series of compression and rarefactions. So this one, it travels, transverse wave travels in a series of crests and trough, while longitudinal waves travels in a series of compressions and rarefactions. So these are the two differences between transverse wave and longitudinal wave. When you move to longitudinal, that is waves 2, you realize that you'll have some that have been left out. But according to as per our knowledge, we can give just the two differences. So this marks the end of the discussions of the three questions. But I would like to give you two more questions that you can attempt when you are free. So let me give you two more questions. So these are the questions that I would like you to attempt. The first question, waves on a spring are produced at a rate of 20 wavelengths every 5 seconds. Find the frequency of the wave. B, if the wavelength of a wave is 0.01 meters, find the speed of the wave. C, find the period of the wave. Then question 2, the figure below shows a wave. Determine the frequency of the wave given that the wave speed is 340 meters per second. So kindly try to attempt this question. This marks the end of our lesson. May God bless you. Bye-bye. Hello learners, I'm called Festus Shondu Wekesa, a teacher of mathematics and physics. Today I'm going to take you through this topic known as heating effect of electric current in physics. and the subtopic or the lesson of today is energy changes and potential difference. The main objective of this lesson is, by the end of this lesson, you as a learner, you are supposed to define heat and electric current. That is 1. 2, be able to explain these energy changes and potential difference. And 3, explain 3 factors determining heat produced by this electric current. Welcome to this lesson. Now, I'm going to explain the key terms in this topic known as heat and electric current. Heat, for you as learners, heat is a form of energy that moves or that is transferred from a body at a higher temperature to a body at a lower temperature until an equilibrium is reached. This area, we covered it in Form 1. Then electric current, we also defined it in Form 1, and we said that this current, it is just a flow of electric charges in a complete circuit. Then after that, the subtopic of today is energy changes and potential difference. Now, this heat, it can be produced from different components. For example, I may have a phone. When I use it for a certain period of time, you may realize that it is getting hot. And I've said, or it is getting warmer. And I've said from the definition, it is a form of energy. So when you touch that gadget or that component, you realize that it is hot. So that is a form of energy. Even a dynamo on a bicycle, you may see that this energy is being transformed to light. When a dynamo is connected or it is on a motorbike, or we have a bicycle, you realize that energy is being transformed. So current is being transferred from one form to another. Charges are flowing from one point to another. That is the current. So when you connect a circuit, you realize that we have some components that they may become warm when you are using them. For instance, I know that if you have come across something like iron box, when you are ironing clothes, you realize that it may reach a time that the iron box is warm. So in that state, we always say that current is being transferred from one point to another. Then that iron box being warm, so it simply means that we have some form of energy, that is heat, that is being produced. Now, for today's lesson, the current, when it is flowing, it produces some heating effect on a coil. And that current, when it increases, then the amount of heat that being produced, it also increases. So learners have said that I've defined the term heat, and this heat I've said that it is just a form of energy that transfers, that is form of energy that moves from a body at a higher temperature to a body at a lower temperature. So it reaches a state whereby when you are feeling that form of energy, it reaches a state whereby you cannot detect whether it is cold or warm. For instance, during morning time, you may find that a chair is too cold, but after some times, you realize that the chair, it is warm. So that state where the chair, it has attained some equilibrium, whether you cannot determine whether it is hot or warm, that state we normally call it thermal equilibrium. It is equal. It is not cold and it is not that warm. Then after that, I've defined the term current. And I've said that current, this one, it is just the flow of charges. Current. This one is the flow of charges from one point to another in a complete circuit. And a circuit, it is just a connection of connecting wires that allows these charges to flow. Sorry for that. So this electric current produces heating effect. I have used an example of electric iron box. I have used an example of electric kettle. I have used an example of this dynamo on a bicycle. So during that time, you realize that it is warm. So meaning that that electric current, when it is flowing, it produces some heating effect. So I have said this electric current, the electric current produces some heating effect, produces heating effects in coils. These coils, it is just a connection of wires in number of turns. So connecting wires. So when we have that connection of wires, so then when current is flowing through it, so it has that heating effect in that coil. So a higher current produces more heat. When we allow more current to flow, then it simply means that more heat is being generated. So we can as well say that a higher current, that is a higher current, produces more heat. So heat and current is directly proportional to each other. When I increase current flowing through that circuit, then it simply means that heat that is being produced, it is also increasing. Now, we have this issue of electromotive force. So what normally causes this heat? What normally causes this heat in these components? It is because of the resistance between the direction that is being moved by the current and the direction of charges. Remember in Form 1, we said that charges and electric current, they always move in opposite direction. So that resistance is the one that normally causes the heating effect in that component. So if you may be asked in exam, what normally generates this heat in a component when current is flowing? So it is very simple. You just say that it's just because of the resistance between the direction that is being moved by the charges and current. So that is the cause of this heating effect. So we can say the electromotive force, the electromotive force of the battery forces a flow of electron around. It forces around the circuit against resistance. Around the circuit against the resistance offered by various components. Offered by various components. So the resistance is the one that normally makes that component to be warm or to be hot. So that resistance between the flow of current and the flow of charges is the one that leads to the production of that heat. So if the amount of heat produced is increased, then the coil may get red hot. If that amount of current heat produced is increased, then it simply means that that component it becomes red hot. So you can say if the amount of heat is if the amount of heat produced is increased if the amount of heat produced is increased, the coil may get red hot. The coil may get red hot. The coil may get red hot. And remember, I've said this heat, the only way we can increase it is by increasing the current. The current, a higher current produces more heat. So when we increase this heat, meaning that current has been increased, so the coil may get that more hot or get red hot. Then further heating, you may realize that we may get another component, for example, a bulb in a torch. After allowing more heat to flow through it, you realize that it gets burned. So when we allow this more heat to flow through the metal, it causes some break from the crystal lattice, making the wire to melt. So when that wire melts, so it does not allow that flow of current. So I may say that further heating will cause metals to break. So when we continue heating, so further heating may cause the metal to break. So it may cause the metal to break free. So if it breaks free from the crystal lattice, so when it has broken, so by making what? The wire to melt. So from the crystal lattice, making the wire to melt. So when that wire has melted, so it simply means that it does not allow the flow of this current. So that component, it does not function. And I know most of the time you may realize that you have even a charger that you are supposed to use to charge that phone. But when you are connecting, that current is not flowing through it. That simply means that a component inside that charger, it melted because of excessive production of heat. So that is how this heat is produced. So the next part of this topic as a lesson, as I had mentioned in the objective, is to explain these three factors that determines heat produced by electric current. So we have factors determining heat produced by electric current. Factors determining the heat produced by electric current. So here we have three factors that normally determines the flow of this, that normally determines heat produced by this electric current. Most of the times, when you overcharge, when you charge a device, when you allow more current to flow through that device for a longer period of time, you will realize that that device or that component, it gets hot or more hot. Now, meaning that the first factor in this area, it is time. When you overcharge for a longer period of time, so it gets more hot. So meaning that time and electric current or heat produced is directly proportional to each other. So we have the first one is time. The first one is time. Time, this is just a topic in physics in Form 1, and we defined time. We said time, this one is just a measure of duration of an event. So measure of a duration of an event. For example, a lesson, it may take 20 minutes. That is an event. That is the duration. So time. So time, when we hit a component, when we allow currents to flow through that component for a longer period of time, that simply means that more heat is being generated. So that simply means that this time heat produced is directly proportional to what? To the heat. Time and heat produced is directly proportional to each other. So we can say that heat produced by an electric current device, heat produced by an electric current, is directly proportional to the time taken. So heat produced by an electric current is directly proportional to each other. That simply means that directly proportional, it simply means that when time increases, then heat produced also increases. I can illustrate it using a graph. For example, if I may have a graph here, as showing the relationship between time and heat. So we may have here heat, then we have here time. Time being measured in seconds, then heat in joules. So meaning that if time increases, the heat produced also increases. So we always have a straight line passing through the origin. This shows the relationship between heat produced and time. So the graph here illustrates or shows how increase in time increases what? It shows the corresponding increase in that heat produced. This is the first factor, time. And the second factor is resistance. The second one is resistance. Resistance of a component. Resistance of a component. So resistance, we may talk about the resilience of that object to sustain some heat, or the length of that object. So when the length of object is long, so meaning that it requires a lot of heat to make that object gain some heat. So similarly, resilience, because in Form 2 work, we talked about these things of resistance and current and voltage from Ohm's law. And you realize that resistance, we have devices with different resistance. We may have a device of 10 ohms, we have 20 ohms, we have 100 ohms, we have even 1000 ohms. So this one simply means that that component of a device with 100 ohms is there to sustain a lot of current that normally flows through it. So here similarly, I can say that even here, heat produced by an electric current is directly proportional to the resistance of that component. So here we can also say that heat produced is directly proportional to the resistance or length. We can put this one into bracket. So resistance or length of the component. Resistance. So heat is directly proportional to that one, to heat, to that length or the resistance of that object. So when the resistance is high, so more heat is also produced. Similarly, we can illustrate it using even the graph. That shows that it will also produce a straight line passing through the origin to illustrate that increase in resistance also increases heat transfer. Then the last factor here, number 3, we have the current. And current, as I've said from the introductory part, I've said that if more current is allowed to flow through the device, so it produces more heat, meaning that it is also one of the factors that affects or that determines the heat produced by by electric current learners. Now here, from the introductory part, it simply shows that this current flowing through an electric device or component is also directly proportional to the heat produced. So I can say again, heat produced here, heat produced is also directly proportional to the electric current. Directly proportional, directly proportional, directly proportional. Directly proportional simply means that increase in one quantity results in the increase in the other quantity or variable. So when I increase current, then it simply means that I have also increased the heat that is being produced. Then after that, I can summarize these 3 factors using one relationship. I can summarize the 3 using the 3 relationship. So summary, because now the common figure here is heat, 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 and the 3 parameters, they are variable, they are varying. So I can say that this heat, then sign of proportionality is equals to I squared. Then we have RT. Experiment, it has shown that here, this one, it is heat is directed to the, okay, sorry, here, it is directly proportional to the square of current. Square of current, not just current, but square of current. So current, we must square it, but the other variables, they remain the way they are. So generally, we can summarize that equation using this one. And when I remove this sign of proportionality, so I have my equation as H equals to I squared, then RT. This one, it is known as Joule's law. Joule's law of electrical heating. It is a law. So Joule's law of electric heating, it is stated as this one, H, heat. This stands for heat. Then I stands for current. Then you have R stands for resistance. Then T stands for time. So I can say this H, this one is equals to heat, or it is heat, then I is equals to current. Then we have R, resistance. Then we have T, stands for time. But we may find that we have other books. This Joule's law, they may replace H with E. This E, we may have this H, or we may have E. This represents what? Energy. So other books, they may state this relationship between the three components as E equals to I squared RT. So it is just the same thing. H and E, they simply mean the same thing. Now, if somebody may ask you to state Joule's law of electrical heating. Joule's law of electrical heating, we just derived the law from the three factors that determines heat produced by this electrical current. So we may say that this Joule's law of electrical heating, Joule's law of electrical heating states that the energy developed. So it is going to be energy or heat, because we are talking about heat, and I've said here heat and energy, it is just the same thing. So this heat or energy developed in a wire is directly proportional to 1. Now I've said we are just summarizing the three factors. Is directly proportional to the square of current, time taken, square of current, we can denote it as I squared, then time taken, that is T, and the resistance R of the wire, and the resistance R of the wire. Now this is Joule's law of electrical heating, which states that the energy developed in a wire, but this wire previously I've used a coil, and a coil or wire, because I had said a coil is made up of wire, is directly proportional to the square of the current I square, time taken, this one we can use T capital, and the resistance R of the wire. That is the Joule's law of electrical heating. Now this marks the end of the lesson of today, whereby our main objective was to define heat, then electrical current, then also to show how this electromotive force moves in terms of energy changes and potential difference. Then we also explaining factors determining heat produced by electric current, whereby I've explained we have 3 of them. Time, I've explained that one as heat produced direct proportional to the time taken. We have resistance, then we have current. And I've said these 3 factors, they are summarized using this Joule's law of electrical energy, which states that this one I've stated, it is there. I've explained the letters that it represents. We have H, I, R, and T, then E. But remember, learners, this space in mathematics or in physics, it simply means it's multiplication sign. You can as well put there multiplication, or if you leave, there is no problem. Now, for the assignment of today, you can as well write down and try these questions at home. So the first one, kindly define the following terms. One, we have heat. Then two, we have current. Then you can as well define this one, temperature, because this temperature I've mentioned it somewhere here, but remember we covered in Form 1 temperature. Then the second question, explain three factors determining heat produced by electric current. So this is the assignment that I would like you to try when you are at home, and when we meet next time, we shall apply this formula relating current, resistance, and time. Thank you.
Welcome to Manifested Publishers.
Hello learners, welcome to Manifested online classes. My name is Mr. Mwaniki. Our lesson today is about gas laws. Gas laws is the first chapter in Form 3. I want first to take you through the objectives so that you understand the expected outcomes by the end of this chapter. Therefore, we look at the objectives. The first objective by the end of the chapter, the learner should be able to first state Boyle's and Charles' law. State Boyle's law and Charles' law. The second objective, describe experiments to illustrate Boyle's law and Charles' law. The third objective, you state and use the combined gas law in numerical calculations. So state and use combined gas law in numerical calculations. The fourth objective, state Graham's law of diffusion and relate the rate of diffusion of a gas to relative molecular mass of a gas. State Graham's law of diffusion and relate the rate of diffusion of a gas to the relative molecular mass of a gas. And lastly, explain diffusion in terms of kinetic theory of matter. Explain diffusion in terms of kinetic theory of matter. Therefore, those are our 5 objectives in this topic, gas laws. Just to go through the objectives, by the end of this chapter, the learner should be able to 1. State Boy's and Chow's laws. B. Describe experiments to illustrate Boy's and Chow's laws. C. State and use combined gas law in numerical or mathematical calculations. D. State Graham's law of diffusion and relate the rate of diffusion to the relative molecular mass of a gas. And lastly, explain diffusion in terms of kinetic theory of matter. So those are our 5 objectives. You need to understand and be able to do everything about this topic. Then by the end of the chapter, you should have achieved all our 5 objectives. Into this lesson, still I want to define 2 terms. Definition of terms. Definition of terms. I'm going to define 2 terms. The first one is gas, and the second is law, which are forming part of our chapter, because our chapter is gas laws. Gas laws. So the first term I want to define is a gas. We say that a gas is a physical state of matter that has a definite mass indefinite volume and definite shape. Therefore, a gas is a physical state of matter that has a definite mass, indefinite volume, and indefinite shape. Therefore, the properties of a gas, you can deduce them from that definition, that a gas has a definite mass, it has an indefinite volume, and it also has indefinite shape. That is a gas. The second term is law. A law is a statement of fact deduced from the observation to the effect that a particular natural or scientific phenomenon always occurs if certain conditions are present. Therefore, a law is a statement of fact deduced from observation to the effect that a particular natural or scientific statement is a statement of fact deduced from observation to the effect that a particular natural or scientific phenomenon occurs if certain conditions are present. Therefore, it must be a fact. So it's a fact. And this fact must come from observations. So you must have done experiments and you've observed that this is a fact. And again, there are certain conditions which must be present and which we are going to discuss later in this chapter. Talking about laws, in this chapter we have 4 laws which we will be talking about. Boyle's law, Charles' law. The third is a combined gas law. And the reason why we are calling it combined gas law, it is because it combines both Boyle's and Charles' laws. That's why it is called combined gas law. And lastly, we have the Graham's law of diffusion. Graham's law of diffusion. Those are the 4 terms or the 4 laws we are going to study in this chapter. Therefore, you need to know correct definition for these 2 terms, a gas and a law. Therefore, the gas laws, we can say that it is that physical state of matter which has a definite mass, an indefinite volume, and indefinite shape, which has certain facts which are deduced from certain conditions which we are going to discuss or learn them later in this chapter. Therefore, in this lesson, I wanted to give you just the expected outcomes in this chapter, which were the objectives and define these two very important terms which we will be illustrating and discussing them deeply in the chapter. I will leave you with this assignment. The assignment is one, state three properties of gases. That is the first question. And question number 2 is define the term law. State three properties of gases and define the term law. The next lesson, we will discuss Boyle's law. Thank you for being part of the lesson.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we are going to discuss Biology Form 4, and the topic of discussion is genetics. Now, first of all, before we get into details about genetics, it is important to understand what a learner is required to know by the end of this particular chapter. So basically what I'm saying is that we'll discuss the objectives of the chapter first. So the chapter objectives are as follows. 1, the learner by the end of the chapter should be able to distinguish between continuous variation and discontinuous variation. After that, the learner should be able to describe the structure of a chromosome and its function. So describe the structure and function of a chromosome. Of course, the chromosome is the one that carries genetic material. Number 3, the learner should be able to explain the first law of inheritance, and Mendel's work. So basically what we are saying is that the first law of inheritance was formulated by a person called Gregor Mendel, and we'll be in a position to explain what work did this person do in order to come up with the first law of inheritance, also known as the law of segregation. After that, the learner should be able to construct and use a Punnett square to construct and use a Punnett square is a genetic diagram that shows how offsprings are arrived at from the parents. Then after that, The learner should be able to distinguish F1 and F2 generation, genotype, phenotype, homozygosity, heterozygosity, linkage, etc., and other terms that are applied in genetics. Number 6, the learner should be able to predict and explain genetic disorders, the likelihood of genetic disorders by, of course, carrying out some genetic crosses. Also, the learner should be able to explain the A, B, O blood groups, rhesus factor, and their inheritance. And basically how those are inherited. And number 8, the learner should be able to explain chromosomal mutations. Explain chromosomal mutations. And lastly, number 9, I should be able to explain the practical applications of genetics. So just to go through the objectives of this particular chapter, we are saying that the first objective, the learner should be able to distinguish between continuous variation and discontinuous variation. That is as part of the introduction. Describe the structure and function of a chromosome. 3, explain the first law of inheritance and Mendel's work, also known as the law of segregation. Construct and use a Punnett square. This is a genetic diagram. 5, to distinguish between F1 and F2 generation, genotype, phenotype, homozygosity, heterozygosity, linkage, etc. And some of these are the terminologies that we use in the study of genetics. The learner should also be able to predict and explain the genetic disorders. What are the likelihoods of experiencing a genetic disorder? We can be able to predict by carrying out some genetic diagrams. Excuse me. Number 7, the learner at the end of the chapter should be able to explain the ABO blood groups, the rhesus factor, and how they are inherited. Number 8, to explain chromosomal mutations. And lastly, number 9, to explain the practical applications of genetics. So first of all, I will start with an introduction. So having gone through the chapter objectives, we'll now have an introduction to genetics. And first of all, I will start by explaining the term genetics. This is one of the branches of biology, and we say that this is the study of inheritance and variation. So in other words, what we are saying that in genetics, we shall be studying inheritance and variation. And when you talk of inheritance, we'll be studying the transmission, of characteristics from parents to offspring. We want to see how characteristics are transmitted from parents to their offspring. Now, these characteristics that can be transmitted from parents to offsprings, we refer to them as inheritable characteristics because they can be transmitted or transferred from parents to offsprings. We have other characteristics that we call acquired characteristics, and these are characteristics that are obtained from the environment. They are characteristics that are obtained from the environment, and those ones are not basically, they are not mainly obtained from the parents. So the characteristics obtained from the parents are referred to as inheritable characteristics. Inheritable characteristics. For example, something like sex is inheritable. It's your parents who determine the sex that the offspring will have, or the child will have. So we also have something like blood groups, etc. So those are examples of inheritable characteristics. So those ones are not acquired. They are not acquired during the lifetime of a person or of an organism. They are something that one is born with, and they cannot change. So on the other hand, we have acquired characteristics. These ones are obtained from the environment. In the course of the organism's lifetime. So this is something that is acquired from the environment in the organism's lifetime. For example, we can have, e.g., something like a resistance to diseases, or adaptability is something that is acquired from the environment. We'll be looking at more characteristics that are acquired from the environment. Now that genetics is the study of inheritance and variation, it's also important to understand what variation is all about. And we say that variation refers to the differences that exist between living organisms of the same species, a human being and another human being. What are the differences that exist between those human beings? So we refer to those as variations. For example, we have brothers and sisters who come from the same parents, but they are not necessarily identical, or they do not look exactly like each other. So there are some variations between them, or there are some differences between them. So we're saying that variation refers to differences that exist between living organisms of the same species. e.g. we can say between a brother and another brother do not look exactly identical. They do not look exactly identical to each other, despite having the same parents. Despite having the same parents. So in as much as these brothers have the same parents, same father, same mother, they do not look exactly identical, or they don't look exactly the same. And that is because there are variations that happen between the organisms, or between even the human beings of the same parents. So we shall look at what causes those variations much later. First of all, I would like us to discuss the types of variations. Types of variations. So we have two types of variations. We have one, what we call discontinuous variations, and two, we have continuous variations. So in our next lesson, we'll be getting into details about what are the discontinuous variations, what are the continuous variations. But just to have an overview of what we've done, we've gone through genetics as the study of inheritance and variation. We have seen what is inheritance, how characteristics are transmitted from parents to offspring, and those characteristics that are transmitted from parents and to offsprings, we have referred to them as inheritable characteristics. And they include just a few to mention: sex and blood groups. It's something that one acquires from the parents. On the other hand, we have characteristics that are obtained from the environment. These ones are acquired. It's something that is acquired. For example, resistance to diseases. One may get immunity to a certain disease because that person has been exposed to the disease. So that person may build immunity. So that's something that is acquired with the time. Variation, this refers to differences that exist between living organisms of the same species. And we've said that even if organisms have common parents, they don't have to exactly look identical. They don't have to exactly look the same. There are some slight differences in terms of the skin color, maybe the shape of the nose, and so on and so forth. So we refer to those as variations. And then finally, we have said that there are two types of variations. We have discontinuous variations and continuous variations. So from there, we'll have an assignment on what we have learned. So the first question, define the following terms: genetics, A, and B, variation. And number two, name the two types of variations. So we'll stop there for today. Until next time, goodbye.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we are going to discuss a Form 4 topic in chemistry, and this topic is reaction rates and reversible reactions. So the topic is reaction rates and reversible reactions as indicated here. Before we get into the details about the topic, it is important to first of all understand what is the learner required to understand by the end of this particular chapter. So we shall first of all go through the objectives of this particular chapter. Chapter objectives. First of all, we should be able to define what is the rate of reaction. We should be able to define what is the rate of reaction, as the topic suggests reaction rates. So we should be able to define the rate of reaction and also explain a concept that is referred to as activation energy. So define the rate of reaction and also explain activation energy. So that's one of our objectives. Number two, we should be able to describe some of the methods that can be used to measure the rate of a reaction. So to describe methods that can be used to measure the rate of reaction. Then number three, we should be able to explain some of the factors that determine the rate of reaction. Explain some of the factors that affect the rate of reaction. After having done that, we should be able to draw graphs and interpret data from those graphs, targeting at measuring the rates of reaction. So we should be able to draw graphs and interpret data from those graphs, the data that is pertaining to measuring the rate of reaction. Then number five, we should be able to explain now the second part of the topic, reversible reactions, simple reversible reactions. And lastly, number six, we should be able to explain the concept of equilibrium. The concept of equilibrium and factors that affect the equilibrium. So basically, those are the objectives that we need to fulfill by the end of this chapter. So we are saying that we should be able to define the rate of reaction and explain the term activation energy. Number two, we should be able to describe methods that can be used to measure the rate of reaction. Number three, explain some of the factors. Explain some of the factors that affect the rate of reaction. Then we draw graphs and interpret data pertaining to measuring the rate of reaction. Explain simple reversible reactions and also the concept of equilibrium and also the factors that affect the equilibrium. So having done that, now we'll start on the topic. So we're going to look at the concept reaction. And to start us off, we can say that the rate of a reaction simply refers to the speed at which a reaction occurs. For example, we know that there are some reactions that we carry out and then we get the results immediately. For example, during precipitation, if you have, for example, sodium sulfate and barium nitrate, and then you combine the two solutions together, you will get a precipitate immediately. So that's a reaction that occurs very fast. So you can say that the rate of reaction is high. On the other hand, we have an example of a reaction like rusting of iron. Is a reaction that takes a number of days before that reaction can take place. So we are saying that we have different reactions that take place at different rates. So you can say that some reactions occur immediately, e.g. precipitation of barium sulfate after combining sodium sulfate and barium nitrate. So that's a reaction that occurs immediately. Maybe you can write the equation: sodium sulfate solution plus barium nitrate, also a solution. So the two will precipitate from barium sulfate, which is a white precipitate, and sodium nitrate, which is a solution. So we are saying that that's a reaction that occurs very fast, white precipitate. On the other hand, we can give another example. On the other hand, the rusting of iron takes several days. So that is a slower reaction. So we can therefore say that the rate of reaction, therefore, is the rate at which reactants are consumed. Reactants are consumed or used, or products are formed in a reaction. Is a measure of how fast or how slow are the reactants getting used, or are the products being formed. So because you know that in a reaction we utilize the reactants and then when we form the products. So basically we are talking about the speed of a reaction. The speed of a reaction. And to determine the speed of a reaction, possibly we can measure the change in mass. Some of the properties that we look out for: change in mass, maybe change in volume if there is a gas that is being produced, and so on and so forth. So we are saying that some of the properties assessed include the change in mass. How is the mass changing? The volume of gas produced. You can also measure the intensity of color change, etc. So those are some of the properties assessed during the determination of the rate of reaction when we are determining whether a reaction is happening faster or slower. Then there is another concept that we'll introduce as we have seen it in the first objective, and this is the concept of activation energy, that is abbreviated as EA. And we say that this is the minimum amount of energy that we need to overcome so that a reaction can take place. So we can say that this is the minimum amount of energy required for a reaction to take place. Or in other words, we can say that this is the barrier to a chemical reaction. So we must overcome that barrier so that the chemical reaction can take place. So we can have a short assignment on that. So in the assignment, there are 3 questions. What is the rate of a reaction? Number 2, name some of the changes that are used to determine the rate of a reaction. Then what is activation energy? So basically, that is what we have learned in our today's lesson. We'll continue from there.
Welcome to Manifested Publishers.
Hello students, welcome once again to our today's lesson. We're going to have a lesson in history and government, that is Form 4. We're going to have a lesson in history and government. That is the lesson we are going to have today. And today we are going to introduce a new topic. We are going to introduce a new topic, which is the second topic, that is international relations. International relations. So I hope you are doing well as you continue to learn. And today we are going to introduce a new topic, international relations. Previously, we have learned a topic, or we have been studying a topic that we called world wars, and we studied the different wars, and we said world war is a war that engaged many countries and was fought in more than one continent. And we discussed in detail the world wars that have been experienced in the world. That is the First World War, the Second World War. We interrogated the different countries that were involved in this war. And now we are going to take a step further and look at international relations as our new topic. So from what we learned in our previous topic, that is the world wars, we discovered that the world war was not a very good. The world wars that were engaged, that people were engaged in the world, were not very good. They had devastating effect on the economies of people. They had serious effects on the lives of people, because we mentioned that a lot of lives were lost. Countries spent huge amounts of money during this war. So immediately after the Second World War, there was now a period of peace, and now the countries were motivated to find amicable ways of solving their issues. They had to find ways in which they could interact with each other, or nations could be able to have relations with other people. That is what we are going to be discussing and studying in our topic, international relations. We are going to ask ourselves, how did now, from the war moving forward, because initially countries were so much psyched up against one another, trying to compete against one another, until there was an outbreak of war. Now, because they have seen, they have tasted, the countries have tasted and have seen the effects of a world war. Now, what steps did they take? What were the steps that were taken to make sure that there was now a period of peace, or if there is any conflict, if there is any, right, the people or the countries could be able to interact or be able to view each other or solve their problems in a more amicable way. So that is what we are going to be discussing in this topic. So we are going to start with how, the first thing that we are going to look at, how do people, or methods or ways of interaction. Remember, initially, nations were competing against one another. They were competitors. But now, we are now, after the First and the Second World War, there were now new ways in which nations could interact with one another. That is one thing that we are going to be looking at, or we are going to be studying in this topic, international relations. And then we are also going to look at the organizations. The organizations which are international. The organizations that were created to make sure that there was a period of peace, or people could interact with one another. And among these nations, we are going to look at the United Nations. That is the first organization that we are going to look at. Then you're also going to look at the Commonwealth. I'm sure you have been able to hear that word. We are going to now to interrogate and learn what does it, or what is this organization. And then we're also going to look at the other one, the non-aligned movement. Let me write it. It's non-aligned movement. We are going to be discussing more. So when we talk of this, we are going to be asking ourselves, how are they formed? We're going to look at their formation. We're going to learn about their formation, how they were formed, and then their structure or organs. How are they structured? How do they carry out their activities? That is another thing that we are going to be discussing in each of these. And then we're also going to look at their performance. We're going to look at their performance. We're going to look at their performance. How did they perform? Were they able to succeed? Did they fail in any way? Do they have shortcomings? We are going to be discussing each and every organization that we are going to look at. We are going to look at their formation, how it was formed, then the organization, the structure, how is it structured? Because we are saying it involves many countries, oftenly across continents. So how are they structured? How do they carry out their activities? That is the organ or organization. Then you are going to look at the performance. What are the achievements, if any, of these organizations? Or if there is shortcomings, you're also going to be discussing that in this topic. The other thing that we are going to be discussing in this topic is the Cold War. The Cold War that ensued. We are going to define what the Cold War is. Immediately after the Second World War, countries or the two blocs that had been formed, that is the capitalist and the communist blocs, the Western and the Eastern blocs, how they were fighting. Now, this was not a physical war like the World War that we had discussed in our previous topic. Now, this was war of words, war of propaganda or economic sanctions, one country or one nation sanctioning another nation. And then lastly, we are going to be discussing the non-aligned movement as part of the international organizations or a movement that involved many nations. So, in a nutshell, these are the issues we are going to be dealing with in this topic when we talk of international relations. So, to start us off, my dear learner, let us start at looking at the methods in which countries interacted or countries interact in the world we are living in today, and especially which with reference from the time of the Second World War, when the Second World War ended until now. How have nations been interacting? So, methods or ways of interaction. Ways of interaction. So, that is what we are going to discuss to start us off in our today's lesson. So, I've mentioned immediately after the First World or the Second World War, there was a period of peace. Nations could now come together. They saw the importance of them coming together and sticking together, trying to solve their problems amicably as opposed to threatening or attacking the other nation. So there are different ways in which independent nations, remember we are talking of states or countries that are independent from the other. So how do they interact? So the first way in which they interact, the first method of interaction is political relations. Political relations. So when you talk of political relations, this involves, let me underline this so that there is, so when you talk of political relations, this involves ideologies. It involves ideologies. When you talk of an ideology, is the driving power or the understanding. What drives a person? The belief system of a nation or of a group of people. That is the ideologies. So different countries that had the same ideologies came together. They made alliances or they made unions to come or discuss the issues because they have the same thinking pattern. They have the same way of handling issues. That is the ideologies. And even beyond the different ideologies, as we are going to discuss in the coming lessons, you'll find that nations found a way of accommodating even competing ideologies. So when you talk of ideologies, there are two major ideologies that existed at the time. We had the capitalist ideology that was adopted by the Western Bloc. I'm sure you have already learned that, which was happening during the Second World War, the Western Bloc, and then we had the communist ideology that was held by the Eastern Bloc. This was led by the USSR. I'm sure you have already discussed that. So these were the major ideologies in the world. The communist ideology, and they had the capitalist ideology. So these were the ideologies that were driving the world at that time. So nations that had a capitalistic view, right, could come and could easily interact with one another, and the communists also. But of importance to note is that even post the Second World War, these blocs found way of interacting. Yes, they have different ideologies, but they started borrowing ideas from others. So you'll find nations that would adopt part of capitalist ideology and part of the communist ideology. So that is the first way in which countries or nations that are sovereign, I want you to remember that each nation is independent from the other, found ways of interacting. The first one is political relations. The second one, we are going to discuss the economic relations. Economic relations. So this involves adopting trade treaties or trading with one another. So when you talk of economy, remember in history, when you hear the word economy in history, you are talking of the livelihood of people. So economic relations involved trading activities. Trade. So nations started to trade and export and import from their neighbors. You'd find countries that initially were not or were hostile to one another, post the Second World War, they could now start interacting or finding trade or markets or a source of raw materials from even the countries that were competing with them. So after the Second World War, countries found ways or relaxed their restrictions to trade. So they would work together. They would exchange. They would now started using of common currency. Common currency was another way. Common currency. So you'd find nations using the same kind of currency so that to ease their trade activities with one another. That is another way in which they could interact. Also, you'd find a country giving loans and grants. You'd find a country that is more economically empowered, for example, the USA, giving other nations loans so that they could revive their economies. Remember, one of the effects of the world wars was the economies of the world came to almost most of them. There was a very great depression or recession in the economies. So they had to revive their economies. So they had to loan each other. They had to loan, that is, give monies to help economies to be revived. They also give grants. Grants is money that is given out and you do not expect it back. It's like a gift. So in times of, when you talk of economy, there are countries that could able to be share their economies, or they could share their economic knowledge, and also giving physical loans or physical money to make sure that countries their economies do not go down, right? So that is another way in which the countries were able to interact. Remember, we are talking of an international organization or international interactions. So countries from different continents were able to interact in terms of trade and even having the same currency, and as I've explained, having the loans and grants given to them. Apart from that, there was also diplomatic relations. That is number 3. Diplomatic relations. There are diplomatic relations. When you talk of diplomacy, diplomacy means there is cordial, there is peaceful interactions. So diplomatic relations was another very essential way in which countries or nations in the world now interact. They send, or they have diplomats being sent from one nation to the other. These diplomats, you have heard of ambassadors or high commissioners. So after the World War, nations started sending representatives. Diplomats are representatives of one nation to the other. So you'd find each and every nation striving to have a representative representing the interests or representing that nation in a foreign nation. So you'd find, for example, talk about the nation of Kenya, for example. You'll find Kenyans, we shall send ambassadors to other nations so that they can represent us in those nations, market for what we have, and also find ways in which we can interact with other nations. So that is diplomatic relations. So diplomats were sent from one nation to the other. These made sure that in case there is a problem, these diplomats or these ambassadors or high commissioners could be able to solve the issues that could have risen. Also, apart from diplomatic relations, there is social cultural interactions. There is socio-cultural interaction. There is socio-cultural interactions or interactions. So when you talk of social cultural, that involves, or this involves, exchange of culture and ideas. Countries started exchanging or learning from one another. As a result of the war, people moved from one nation to the other. So when they found out that there are people living or have different cultures than ours, nations started to exchange their ideas. They started to exchange their beliefs, and they could also exchange their skills. So there was exchange of culture. That is the first interaction when we talk of that. People's way of life, beliefs, right? And then also exchange of skills. Exchange of skills. A very good example is in the medical field. In the medical field, you'll find doctors coming from one nation, going to another nation to train the people of that nation or doctors in that nation. You'll find teachers coming from one nation, going to another, so that they can be able to train that other nation that does not have resources. So there was interactions in terms of exchange of skills. A very good example that we have seen in Kenya is when you have seen the Cuban doctors. Doctors from Cuba coming to help or train together with or train the Kenyan doctors, or even just offer their services where they are needed. That is a very good example that we can cite of how the nations have been interacting. Another way in which they have interacted socially and culturally is through games. So you have found or you have heard of different countries coming together to compete against one another in games. They are not competing to fight, no. They are competing as a way of interacting. You have heard of Olympics, right? You have heard of we have our own Eliud Kipchoge who is competing for us. We have heard David Rudisha, right? We have heard Julius Yego, who was competing in the javelin, right? you have also had other competitions like the World Cup, that is in football. So those are ways in which nations today are interacting. So you'll find each and every nation will want to be represented in these games. And as they interact, there is relations or there is peace. And then lastly, there is humanitarian assistance. Humanitarian assistance. So this is where you find, in case there is famine, for example, or there are floods, you find other nations coming to help. Whenever there is a problem, nations will bring in help, or they will come and rescue these nations that have been affected. Where there are refugees, yeah, nations are able to accept people who have run away from their nations because of internal wrangles. That is another way in which nations have been interacting. And then lastly, the last way in which countries have been interacting is through international organizations. International organization. When you talk of an international organization, this is an organization that each and every country or draws membership. Members of these organizations are drawn from different countries in different continents. So for an organization to be an international organization, it has to have members from different countries in different continents. So there were organizations that were created to promote international peace. That was their main aim, promote international peace. That was their main aim. So these were created to bring peace in the world. An example is the United Nations. That is one organization that has been created. It has so many, almost every country in the world is a member of the United Nations. And we are going to be discussing that in our coming lessons. Another one, or another organization, is the Commonwealth Organization. These are different countries that have come together to make sure, or to safeguard, or to make sure that there is peace in the world. And we are going to be discussing very examples, singular organizations that run throughout the world to make sure that there is peace, or see that there is peace being experienced among the nations. So those are the different ways in which the countries of the world are able to interact. I've talked of political relations, that is ideologies, right, or beliefs. Those who have the same system of administration, you will find them coming together. For example, the Commonwealth countries, they were under the British colony. You'll find them coming together. Then we have the economic relations, that has to do with trade and the economies of the world. People will want, or countries will want to be able to work with one another. We have talked of diplomacy, social, cultural interaction. So as we come to the end of our first lesson in this topic, that is an introduction, I would want you to attempt this question, very simple question, to help you attempt, or to help you internalize what we have already, what we have learned today. So we have a revision question, and the question is, identify ways in which countries interact. Identify ways in which countries interact. and I'm sure you are able to attempt that question. So with that, we have come to our history and government lesson for today. I've been your teacher, Conan Gakure. Bye-bye.
Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform, a chemistry lesson. If you remember in the previous lesson, we discussed, or we first of all came up with the objectives which you need to achieve by the end of this chapter. And also, we defined two important terms which we will be using throughout in this chapter. We talked about law and gas, where we said that a gas is a physical state of matter with a definite mass, with a definite volume, with an indefinite volume and indefinite shape. And the law, we said that it is a fact, it is a statement of fact, which is coming from an observation, from an experiment you've done on natural or scientific phenomenon, which occurs due to changes in some conditions, which again we are going to discuss them further in this topic. In our today's lesson, we will start with Boyle's law, because we talked about the four laws, which were Boyle's law, Charles' law, combined gas law, and Graham's law of diffusion. So we start with the first law, which is Boyle's law. So this law was named after a scientist called Robert Boyle. So Robert Boyle was the name of the person who came up with this law, Boyle's law. I want to define this law. Definition. In Boyle's law, states that the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. It states that the volume of a given mass of a gas is inversely proportional to pressure, and temperature must always be constant. The volume of a given mass of a gas is inversely proportional to pressure at constant temperature. I want to simplify it further for you and explain it and say, when we say it is inversely proportional, when we say that the volume of a given mass of a gas is inversely proportional, we mean that when volume, well, this means that when volume of a gas increases, the pressure of the gas decreases. The volume of a gas increases, the pressure of the gas decreases. And when pressure of a gas increases, the volume of the gas decreases. The volume of the gas decreases. When volume of a gas increases, the pressure of the gas decreases. And when the pressure of the gas increases, the volume of the gas decreases. That is the simple way of understanding Boyle's law, that when the volume is high, pressure is low. And when pressure is high, volume is low. I can use this example to explain it to you simply or in a simple way. I can use a small container . In my container, I have this is just a tube. This is the piston. Inside my tube, there is air inside. So there are particles of air which are inside my tube. When I press this piston downwards, it means, one, the volume decreases. So the volume will go down. The volume of the air particles inside my tube will decrease. And at the same time, pressure increases. I know you're wondering how pressure increases. I will explain it to you. The reason why pressure is increasing is because when you press this piston downwards, the volume decreases. And at the same time, the pressure is increasing because the particles, they are now closer to one another. The particles of this air inside this tube becomes closer to each other, meaning that there is more collisions between these particles themselves. There's more collisions between these particles of this air inside within themselves and also within the walls of this tube. That is what is causing the pressure to increase. So anytime volume decreases, pressure increases. Pressure increases when volume decreases. I hope you get that clearly. At the same time, I want you to imagine if you pull this piston upwards. If you pull this piston upwards, this what means is that the volume inside, because now this the volume inside will increase. The volume of air inside the tube will increase. And the pressure will decrease. And the reason why pressure will decrease is because the particles, they now move far apart from one another. The particles of air move far apart from one another. When they move far apart from one another, then there is the effective collisions or the probability of these particles colliding with one another and also with the walls of the tube decreases. And that's how the pressure decreases when volume increases. I hope you also understand that very clearly, because our Boyle's law, we have said that when the volume of a given mass of a gas, or the volume of a given mass of a gas, is inversely proportional to pressure at constant temperature. So temperature always must be constant. So temperature must remain constant at all times. For example, the room temperature, we take the room temperature to be 25 degrees Celsius or 298 Kelvin. That is a constant temperature. So at all time, temperature must be kept constant. There is no variation in temperature. Understand that very well. I will use a live example, and I will use one of my simple apparatus I have. This one is called a dropper. This dropper is having a volume of air inside. There's some air inside this dropper. What happens when I press the upper part? What do you think happens to the volume? The volume is decreasing. And the pressure inside, or the pressure of the particles inside, is increasing. Now to demonstrate that, maybe you can put the dropper on your finger and now press the upper part. When I press the upper part, there's some force exerted on my finger. There's some force exerted on my finger, means that the volume of air inside now is getting its way out, or is trying to get its way outside this dropper, because volume has decreased and pressure, volume has decreased and pressure has increased. That's why that high pressure is now forcing my finger, so that the air can get out. That is a simple demonstration. So it shows that when you decrease volume, pressure increases, and that's why there's some force exerted on my finger. Get that clearly. At the same time, if you release, then it will have, the dropper will have the original shape of the dropper. So there is some air inside at the same time, and there is also pressure, which is inside, because pressure cannot be zero and volume cannot be zero. You cannot have volume of air having zero pressure, and you cannot have pressure when there is no volume again. So volume and pressure cannot be zero. Maybe now to demonstrate it further using a graphical representation, I can draw a simple graph again to explain it to you how when volume increases, pressure decreases, and when pressure increases, volume decreases. I will draw a simple graph to demonstrate that. So this is our y-axis and the x-axis. So this is a graph of pressure against volume. So when you're drawing a graph of pressure against volume, then pressure should be on the y-axis. So we have pressure, which is pressure P, and volume, we have volume V. Now to demonstrate this Boyle's law, then the curve will look like this. That is a curve. Then suppose we have some calibrations, though this ours is not drawn to scale. If you have 0, 10, 20, 30, 40, our scale, and also on the y-axis you have 10, 20, 30, 40, 50, like that. It means that, let's take an example of where the pressure of a gas is at 40. The pressure of a gas is at 40, and at the same time, the volume of this gas is at 10. Pressure is at 40, the volume at 10. Let's take when the volume of this gas is 10, sorry, when the pressure of this gas is 10, we see what the pressure will be. So that is kind of the pressure which will be present. So you see that the pressure is around, let's say it's something like to do with 23 pressure. So this shows you that when the pressure is high, volume will be low. That's why we have the pressure is 40, the volume is 10. And this time we have pressure being 10, the volume has increased. That is the same way I've explained in this one, that if you press the piston downwards, the volume will reduce and the pressure will rise, because the particles of this air inside the tube is colliding more within themselves, those particles, and with the walls of the container. And when you pull it upwards, the volume in the tube increases and the pressure decreases, because the particles inside, the particles inside, they don't collide more because they are far apart from one another. I hope you understand that very well. So you can explain it using the piston, and also I've used a simple graph to explain the Boyle's law. So this is a graph of pressure against volume to demonstrate Boyle's law. Demonstrate Boyle's law. That is what I wanted you to understand in this lesson. But as I finish, I've said that this law was named after a scientist known as Robert Boyle. And we define this Boyle's law as that the volume of a given mass of a gas, the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. So temperature always must be constant. And the simple way of illustrating this, I've said that when volume increases, then you expect the pressure of the gas inside a certain container or a certain vessel to increase. When the volume increases, you expect the pressure, to decrease. And when pressure increases, then you expect the volume to decrease in that container or in that vessel. Then I've used a simple example of demonstrating that using a container or a tube which is having a piston. And I've seen that when you press the piston downwards, the volume inside decreases and the pressure will increase, because there are effective collisions that the particles of this air inside the tube collide more with one another and also with the walls of that tube, and that's why the pressure is increasing. And at the same time, if you pull the piston upwards, the volume inside the tube will increase and the pressure will decrease. And the reason why the pressure is decreasing is because the gas particles or the volume of air inside the tube, the particles are far apart from one another. So the particles are not colliding more fast or more vigorously, and that's why the pressure decreases. That is a simple way of demonstrating Boyle's law. Otherwise, that's the part of our lesson today, and I will leave you with this assignment. And the assignment is I'll give you one question only. Is define Boyle's law. Define Boyle's law. I have defined it for you, so try and see whether you can be able to remember what we have discussed. Thank you for participating in the lesson. See you in the next lesson. Bye.
Hello learners. In our previous lesson, we had talked about the Joule's law of electrical heating, and we had stated that it states that the energy developed in a circuit through a coil or a wire is directly proportional to the resistance, then time taken, and also the square of the current. So today we are supposed to review that or apply that formula in our calculation. And the main objective of today's lesson is, by the end of the lesson, you as learners are supposed to calculate or apply that Joule's law formula in calculation of resistance. We have energy, then you can use the same formula in calculating current. Then after that, the last objective, you may be asked to calculate the number of bulbs that the given amount of power and voltage can be connected to, so that it can supply that amount. So today I'm going to start with the first example. So you can write example 1. So our first question, an electric box has a resistance of 30 ohms and it takes a current of 30 ampere. Calculate the heat in kilojoules developed in 1 minute. So solution. So solution, learners, when you want to make this calculation to be simple, first of all, you must list what you have been given in the question. For example, our first equation here, we have an electric box has a resistance of 30 ohms. So we have been given a resistance. So I write the first parameter is resistance. That is R, which is equals to 30 ohms. Then after that, it takes a current of 10 ampere. So we have a current, we note this one by I, which is equals to 10 ampere. Then the last that we have been given is time, which is 1 minute. So you have time T, which is equals to 1 minute. Now, learners, before you start any calculation, you make sure that the given quantities, they are in their correct SI unit. Remember, resistance is always measured in ohms, current is measured in ampere, then you have time, it has been given in minutes. But in Form 1 work, we say that the SI unit of time is seconds. So we must convert this 1 minute into seconds. And 1 minute is just equivalent to 60 seconds. So this one is just the same as 60 seconds. So after ensuring that the given parameters or variables, they are in their correct SI unit, so we can substitute in our equation. But from our Joule's law, we said that heat is just equals to current squared, then times resistance, then times time. So I want to calculate that heat, and I had said heat and energy, it simply means the same thing. Remember, our question is asking us to calculate heat. So our H is equals to current squared times resistance times time. And I have all these variables here. So I just substitute in my equation. So when I substitute in, we have current, which is equals to 10 squared, then times resistance, which is 30, then times time, which is 60. So this one, it will give us, that is 60 times 30, then times 10 squared. It will give me, that is 180. Then we have, that is 4 zeros, that is 180,000 joules. This is heat. So we have calculated heat in joules, but the question is asking us to calculate that heat developed in kilojoules. So we must go further and convert these joules back to what? To kilojoules. And remember, we said in that the fourth topic, heat energy powered machine, that 1000 joules is equals to 1 kilojoule. 1 kilojoule. So what about these 180,000 joules we have? So we just come and write what about 180 joules here. So we cross multiply like this. So it simply means that I'm going to take 180,000 joules times 1 kilojoule times 1000 joule. So I have 180,000 joules times 1 kilojoule, then over 1000 joules. So these joules and joules, it will cancel. Then you have 1000, will cancel with 3 zeros. So I remain with 180 kilojoules. So this is our energy or heat that was developed within 1 minute by this electric box. So we have these values, we have substituted in, we have converted our energy or heat in joules into what? Into kilojoules. This is our first example. The second example, so the second question is an electric bulb is rated 60 watts, 240 volts. Determine A, the resistance of the filament. Then B, the current flowing through the bulb when it is connected to the main supply. So as I had said earlier, it is good you list what you have been given. From our question here, we have solution. We have been given 60 watts. 60 watts, this is power. So our power, P, is equals to 60 watts. Then 240 volts, that is voltage. Voltage, V equals to 240 volts. Earlier on, we have said that from this application of Joule's law, we have H equals, so H equals to I squared RT. But from part 1, that is A, we are being asked to determine the resistance of the filament. And from example 1, I have said, writing these variables, they will guide you on which formula to use. When we look at this formula, we don't have heat, we don't have current, we don't have resistance and time. We can as well use this formula that we learned in the fourth topic, that is energy, power, work and machine, and we say that this power is equals to V squared over R, that is resistance. So when we make this resistance the subject of the formula, we can say resistance is equals to V squared over power. So we have voltage, then we have power, and we have been given the two variables. So we substitute in our formula. So when we substitute into our formula, we have, that is 240 times 240, then divided by power, which is 60. This one, it gives us, that is 240 times 240 divided by 60. It has 960 resistance, it is ohms. That is the first part. And the second one, that is B, we are being asked to determine the current flowing through the bulb when it is connected to the main supply. B, current. So we have resistance, we have voltage, and we can as well use Ohm's law. From Ohm's law, voltage is equals to current times resistance. We have voltage, we have resistance in our first part. We are being asked to determine current. So we just make this current the subject of the formula. So we have voltage over resistance. So you have voltage, it is here, 240. Then divided by resistance, we have found it to be 960. So when we divide, we can as well use the calculator. We have 240 divided by 960. We have 0.25. The SI unit of current is ampere. So we are done with example 2. That is calculating the resistance of the filament and the current flowing through the bulb when it's connected to the main supply. So we can move to our third example, example 3. Example 3. We have So this is our question. What is the maximum number of 100-watt bulbs which can be safely connected from a 240-volt source supplying a current of 5 ampere? So I had said, first of all, you list what you have been given. You have solution. We have been given the voltage and power, I have power of this power 100 watts. We have voltage 240 volts. Then you have current I, which is 5 ampere. Now for us to calculate the number of bulbs, we equate the two equations. The power supplied is equal to the power consumed by the bulbs. Now because we don't have the number of bulbs, let us denote it by n. Let the number of bulbs be n. Then power supplied is equal to power consumed by the bulbs. Power supplied is given by 240 times 5 equals to power consumed. We multiply by the number of bulbs, n times the power of one bulb, which is 100. So we have 1200 equals to 100n. So when I want to get the number of n, the number of bulbs, I divide both sides by 100. So n is given by 1200 divided by 100, which is equals to 12 bulbs. So that is the number of bulbs that are required to be connected to that power supply of 240. That is that example. So I would like you to try these questions as assignments when you are at home. So assignment. So we have 3 questions that you are supposed to attempt. The first one is an electric cooker has a coil of resistance 5000 ohms. If it is operated on a 240 volts main supply for 1 hour, how much heat energy does it produce? In question 2, how many 100 watt bulbs can be safely connected from a source from a 240 volts source supplying a current of 4 ampere? Then question 3, an electric motor powered by a 240 volts main supply requires a current of 30 ampere to lift a load of mass 3 tons at the rate of 5 meters per minute. Calculate the power input, B, the power output, C, the overall efficiency of the machine. So this one, you can review it. You can try it by reviewing the 4th topic in our coursework. That is for Form 3 work. We discussed about efficiency. That marks the end of our lesson today. When you go home, make sure that at least you review the examples that we have done. We have calculated the heat, the resistance, current. We have also calculated the number of bulbs that are required when we have a common power supply. Thank you. Let us meet next lesson.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariongi, and today we continue with our topic of discussion in biology form 4, and this is genetics. Last lesson, we discussed the two types of variations, and we stated that there are discontinuous variations and continuous variations. So today I would like us to get into details about those two types of variations. So number one, we'll start with discontinuous variations. And we say that these are the variations that have no intermediates. These are variations that do not have intermediates. For example, when you talk of something like sex, is either one is male or female under normal circumstances, and there is no other sex that is in between there. So we don't have an intermediate there. Another example, we have some people who have the ability to roll the tongue into a V shape, like that. So we are saying that those who can roll their tongue, we refer to them as tongue rollers. They have the gene that enables them to roll their tongue. But we have others who cannot. They absolutely cannot roll the tongue. So possibly you can test yourself whether you are one of the tongue rollers or a non-tongue roller. That is a discontinuous variation. It's because you are either on this side or on the other side, but not somewhere in the middle. That's why you're saying that there are no intermediates. Something like blood groups. It's either you are blood group this, A for example, B, AB, or O. So there are no intermediates there, but you have either a specific blood group. For example, also the earlobe. There are those people who have a free earlobe that is detached from the body, and there are those who have an earlobe that is attached. They have those that have a free, and there are those who have an attached earlobe. So that way you cannot do much about it. It's either you have a free earlobe or you have an attached earlobe. So all those examples I've given you are examples of discontinuous variations, and we are saying that these are variations with no intermediate forms. There are no intermediate forms. It means that one either has a particular trait or a particular characteristic or not. E.g., we can talk of sex is either male or female. We can talk of ABO blood groups. You can either have one of those, but no intermediates there. You can talk of tongue rolling, the ability to roll the tongue. It's either you can do it or you cannot. The earlobe is either attached, that is attached, or it's free. So those are examples of discontinuous variations. So they have no intermediates, no in-between traits, but it's either you are on that side or on the other side. Now, These discontinuous variations, they are determined by very few genes. They are determined by few major genes and are not influenced by the environment. They are not influenced by the environment. So that means that they are purely genetic. They are purely genetic. The environment has no effect on your sex. Whether you go to which country or which country, your sex remains either male if you are male or female if you are female. Your blood group will not change. If you had blood group B, it remains B, irrespective of where you go. If you are able to roll the tongue, then you are a tongue roller. You cannot be the other way. So all those are examples of discontinuous variations, and we are saying that they are determined by few. They are not determined by many genes, but by just a few major genes. And also, the environment has no role to play here. There's nothing that you acquire. Everything here is something that you are born with. Let's discuss the second type of variations, and these are the continuous variations. Continuous variations, these ones are those variations with many intermediates between them. They have very many intermediates. For example, if you take something like the height, we have very tall people, we have moderately tall people, slightly tall people, moderately short people, short people. So we are saying that there are so many intermediates. It's like a staircase. Wherever you go, you'll find people. In fact, on this, if you do, for example, an experiment with learners in a certain class, and you take their heights, you may find that it's very difficult to get two learners who have the same height. They will differ, even if by a certain, by a small centimeters, even if they differ with a very small height. So there are so many intermediates, from the tallest person to the shortest person. The same case applies to the skin color. In the skin color, we'll find some people who are very brown, others chocolate, others like that, until you get to the darkest person. So there are so many intermediates that you'll get. So basically, we are saying that height and skin color are they are continuous variations with very many intermediates, very many in between. From the tallest person to the shortest person, there are so many other in between categories. So we are saying that, e.g., height in humans, skin color, body weight or body mass. It's difficult to have people who have the same mass up to the accuracy of a gram. So we are saying that there are so many intermediates as far as those characteristics are concerned. And the reason why is because continuous variations are determined by many genes. So we can say that continuous variations are determined by many genes. So not like the discontinuous, which had just a few genes. They are determined by many genes and are also influenced by the environment. They are also influenced by the environment. Just to give an example, a plant may have some certain genes for tallness, but unless that plant or the seed of that plant is planted in an area where the soil is fertile, where the nutrients are there, then that plant will not grow to its maximum height. If you put it in a place where the nutrients are deficient, then that particular plant may become stunted in as much as it has the genes. So we are saying that the continuous variations are also influenced by the environment. So we can say that, e.g., a plant with genes for tallness may fail to grow tall because it is planted in an area that is deficient of nutrients. Nutrients, water, etc. So if the environment is not suitable, then that plant will not grow tall. We'll also find that we have some people whose skin tend to be dark simply because they have been exposed to very hot environments, especially in the tropics. So that tells you that that heat may affect the skin color. So we are going to have an assignment on that. So the assignment, the first question, distinguish between continuous and discontinuous variations while giving an example of each, or while giving examples of each. Number 2, explain practical experiment that a learner can perform to show the two types of variations. And lastly, 3, what type of variation is represented by a normal distribution curve. A normal distribution curve is one that shows the distribution at every stage, at lower level, at the middle level, and the high level. So we are going to stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi, and today we shall continue with where we reached in the topic reaction rates and reversible reactions. And at this point, I would like us to introduce a concept that we refer to as collision theory. There is a theory that we refer to as the collision theory, and then we shall explain that in reference to activation energy. The collision theory states that a reaction occurs due to collision of the reacting particles. So if you have particles A and B, and those particles are in a certain vessel such that they are able to collide with each other, then we are saying that a reaction can occur, or a reaction can result from there. And in this case, the more effective collisions that are there, because not every collision can lead to a reaction. Not every collision can lead to a chemical reaction. But the more effective collisions that are present, then the faster will be the rate of the reaction. So the rate of reaction is explained by the collision theory, that a reaction occurs as a result of effective collisions between the particles of the reactants. So collision theory and activation energy. And you're saying that a reaction only occurs if there are effective collisions between the reacting particles. When there are effective collisions between the reacting particles. So these particles combine to overcome the activation energy. And also we can therefore define, as we had earlier said, that activation energy is the minimum energy required to cause effective collisions between the reacting particles. So if the activation energy is supposed to be energy, if the activation energy is high, then we need more effective collisions so that we can overcome that activation energy, and therefore the reaction takes place. So we can illustrate that in form of a graph. So we can say that the activation energy is this amount of energy that is required to change these reactants into products. So the gap that is in between here, that energy that is there is what we refer to as EA, or the activation energy. So we are saying that for us to convert these reactants into products, we need to overcome that amount of energy. We need some minimum amount of energy so that that minimum amount of energy can cause effective collisions between the particles so that a reaction can take place. Now, so at that point, we'll talk about the factors affecting the rate of reaction, and we are going to list these factors. One of the factors that affects the rate of reaction is concentration of the reactants. So the higher the concentration of the reactants, we expect the higher will be the reaction. So we don't expect that 2 molar sulfuric acid and 1 molar sulfuric acid can react with magnesium at the same rate. So of course, the 2 molar sulfuric acid will tend to react faster because of its higher concentration, assuming that the mass of magnesium remains constant. Another factor is the temperature. Reactions are affected by temperature, and that's why in some reactions we do heating, so that when you heat, the reaction proceeds faster. So we'll investigate each of those. Then we have the surface area of the reacting particles. Also very important, the size of the particles. For example, if the particles are small in size, then we say that they have a larger surface area. If the particles are very big, then they have a smaller surface area. So the surface area of the particles also matters a lot. Then we have the catalyst. And we know that a catalyst is a chemical substance that alters the rate of a reaction, while itself, it remains chemically unchanged. So the catalyst affects or alters the rate of reaction without being chemically affected. We have light, is also another factor, and this one is common in some reactions. Those reactions that we refer to as photochemical reactions. So photochemical reactions are those reactions that require light for them to take place. So that means that in the darkness, they cannot. And then finally, we have pressure. And pressure is more effective in gases. Yeah. So when we have maybe solids and liquids reacting, the pressure may not be such a very big factor, but when you are dealing with gases, the pressure really determines the rate of the reaction. So those are some of the factors affecting the rate of reaction as we have listed them down. So we'll have an assignment on that. So the assignment, the first question, explain the collision theory. What does the collision theory explain? Number 2, using a diagram, illustrate the activation energy in a reaction. So use a diagram to illustrate the activation energy in a reaction. And then number 3, state 6 factors that affect the rate of a reaction. So we'll continue from there until next time. Goodbye.
Welcome to Manifested Publishers.
Hello, students. I welcome once again to our today's lesson. I hope you are continuing well and you are coping on well with your studies. Today we are going to have a lesson in history and government, a topic that we had started looking at or studying in our previous topic, that is international relations. That is the topic that we are handling. That is the second topic in the Form 4 History and Government syllabus. In our previous lesson, we introduced the topic international relations. We said that this is a period or when countries started to come together to unite and forge peaceful relations or peaceful interactions after the effects of the Second World War. We said the wars brought a lot of harm in the countries. So the countries or people started to find ways in which they would interact. One nation could interact with another and be able to make sure that there is international peace. The biggest reason for the nations to come together was to make sure that there is international peace. And in our previous lesson, as you can remember, my dear learner, we mentioned the different ways, the different methods in which countries interact with one another. Can you remember the ways in which we discussed in our previous lesson? The first one was political interactions. We mentioned that countries with ideologies came together, and even those that had conflicting ideologies were able to interact cordially or peacefully. The next one was economic relations. The third one was diplomatic relations, that is the sending of ambassadors or diplomats. And then we mentioned the social cultural interactions. And then lastly, we studied the international organizations, interactions based on international organizations. And we said an international organization is an organization that encompasses or has members from different countries in different continents. For example, you'd have an organization that has member countries from Africa, member countries from Asia, member countries from America, member countries from Europe. That is an international organization. So that brings us to our today's lesson. Today, we are going to start learning about one of the international organizations that was created to enhance efforts or to drum up efforts to make sure that there is international peace. Remember, a world war involved countries or conflicts between countries, and it involved most of the countries of the world. It was fought on different continents. Now, as opposed to the wars, now the countries were forging ways, or they forged organizations. They instituted organizations to bring the different countries of the world together. So that is what we are going to be discussing in our today's lesson. So today we are going to learn about the United Nations as an organization. Remember, this is an organization, international organization that was created to enhance peaceful. So what is the United Nations? The United Nations is an association of independent states. It is an association of independent states that came together. Is an association of independent states that came together with an aim of promoting international peace. We are saying that the United Nations is an association of independent states. I want you to note that they are independent states. Each state is independent. They have their own ways of life. They have their own constitution. They have their own government. So the United Nations is an association of independent states with an aim of promoting and maintaining international peace. That is the other thing that I really want you to note. International peace. So these independent states or sovereign countries have come together to form an association that is aimed at promoting and maintaining international peace. So all countries come together, irrespective of their political ideologies. notwithstanding their political ideologies. And at that time, we had the capitalist ideology and the communist ideology, and then there now was the African socialism that was also instituted. So all these nations come together, irrespective of their political ideologies, irrespective of their culture, irrespective of their economic development. They do not consider what is your ideology. They do not consider what culture do you have. They do not consider what level of economic development are you in. They do not consider your political views. Right? So all nations, irrespective of how organized you are, or how powerful or how weak you are, this association brought all these nations together so that they could sit down and be able to discuss or interact with one another. So it was formed in a conference that was held in San Francisco, that is immediately in the USA. It was formed during a conference that was held in the USA in a city known as San Francisco. That was in 25th to 26th June of 1945. So immediately after the end of the Second World War, countries came together. They formed, there was a conference that was held here. There were representatives of different nations. There was Franklin Roosevelt, there was Winston Churchill, there was Joseph Stalin. Those are some of the world leaders at then who are leading the superpowers. And even all these other nations were invited, and they came together and decided to form this organization and instituted a charter. They instituted a charter, which is a kind of a constitution or an agreement that was supposed to be ascribed to or accepted by any nation that wanted to be a member of this organization. So these nations came together, led by their leaders. They made an agreement, or they decided to make peace, or make this organization to maintain the world peace. In this conference, there were representatives of over 50 countries that came together to ratify this charter, or ratify this agreement that was made. So they decided to have their headquarters that where these organizations could be operating from. It is in New York, that is in the USA at the same time. So when these countries came together, they did not want to consider the differences they have, the economic strength of a nation. They did not want to consider that. Their main aim was to forge a way of maintaining international peace, as opposed to the organization that was formed after the First World War, which was the League of Nations, that was created as a way of punishing, right, the Allied powers, or those who lost in the war. In this organization, or after the Second World War, they did not want to consider who won the war or who lost in the Second World War. They wanted to bring all of them, both losers and winners, so that they could come and work together and sort out their issues. So this was a way they thought, instead of us continuing to compete or fighting against each other, and they learned from the failures of the League of Nations that had happened immediately after the First World War. So now they included all the other countries. Imagine the first one, at the start of this organization, 50 countries. 50 countries accepted to join into this organization. So membership was open. Any member who wanted to join the organization was allowed to join. Open membership. So any member that could agree to the charter or the agreements or the points that they had raised to in view of maintaining peace. So any member that wanted to join in this membership was allowed to join or was given a time to join. So we are also going to be discussing in the next lesson the organization of these United Nations, which is abbreviated as the UN, right? The UN. So they had to open membership to each and every country. So if a country felt like this is the right way to go, they were allowed to join. The admission for you to become a member or a nation going forward, there was an arm that was brought together that was referred to as the General Assembly. The General Assembly. This was an assembly or a time when the member states representatives, most commonly the presidents or the prime ministers, came together at an assembly. All countries meeting together at one point in one conference. So if a country wanted to join into the UN or the United Nations, he could. That country was supposed to make a request or an application to the General Assembly, which is a body bringing together all the countries. So they would be able to look into the application and then register that new member into that organization. So currently they have the United Nations encompasses or has around 193 members. It has from 50. More countries have joined in up to 193 members. Those are the countries that are party to the United Nations to this time. So we ask ourselves, this was the main idea of them coming together, maintaining and promoting the international peace. So apart from that, which are the other aims of the United Nations? So that is the next thing that we are going to be discussing, the aims of the United Nations. So we shall just be abbreviating it as UN. The objectives. The first one, as we have mentioned, is to maintain world peace. And we have already discussed that. That was their main aim, maintaining world peace and security. Maintaining world peace and security, that is the first one. And then number two, it was to promote peaceful relations. Promote peaceful relations among countries. Make sure that countries are able to relate with one another. And then respect and promote human rights. So this organization made an elaborate outline of the rights of humanity. Each and every person has what rights and freedoms that is contained in the UN Charter. So their other aim was to make sure that the rights and freedoms of individuals are maintained. And then also they had to promote social programs and living standards of people. Promote social programs, and living standards of people. Promotes social programs and living standards of people. So they institute different programs to make sure that the living standards of people, especially from poor nations, have been brought or have been uplifted. And also it is to prevent another war, prevent outbreak of another war. Prevent the outbreak of another world war. So it was to make sure the duty of the United Nations as an organization is to make sure that there is no any other world war that is going to exist or is going to break out in the world war. And also, number 6, protect the marginalized groups. Protect the interests of the marginalized groups. An example is women. Traditionally in our societies, women have not been given an equal opportunity as the men. So the United Nations was given the mandate, or they took upon themselves to make sure that the rights of women, for example, as a marginalized group, has been protected. Another marginalized groups are the children. They have also been protected. Others, another marginalized group that we can mention are those who are disabled, that they are given, their interests have been taken care of. And also promote economic reconstruction of member states. Promote economic reconstruction of member states. One of the biggest effects of the Second World War was that there was a lot of destruction of resources, infrastructure. Most of the countries were almost becoming bankrupt. So the duty of the United Nations was to maintain or make sure that the economies have been reconstructed and there is continued peace. And then lastly, we can mention it is to promote international cooperation. Promote international cooperation. That is the next aim or objective of the United Nations. It is to promote international cooperation. So those are just some of the duties or the aims of the United Nations. They are quite varied, and we are going to be discussing more when we look at the organization or structure of the United Nations. So these are just a mention of some of the aims. You can also do more research and find out what are the other aims of the United Nations. So as we end our lesson today, let me give you a question, a revision question for you to work out as you continue to study. So let us look at our revision questions. The first question is, where is the headquarters of UN located. So in which city? Where is the headquarters of the United Nations located? And then number 2, outline the aims of the United Nations. Outline the aims of the United Nations. And my dear learner, I'm sure you are well able to discuss or mention those aims that we have just listed as being the objectives or the aims of the United Nations. So that brings us to the end of our lesson today. Bye-bye.
Welcome to Manifested Publishers.
Hello, Lana. I hope you are faring on well. Welcome to our today's history and government lesson. Teacher Conan Gakure, and it's an honor to have you in our today's lesson. We are learning about the international relations. International relations. That is the topic we are handling as the second topic of Form 4 work. And we introduced in our previous lessons, we discussed or have learned what international relations are, and we said are the interactions between different countries, peaceful or organized relations or interactions of different countries. And we said there are different ways in which countries interact. I hope you are able to remember them. Also, we learned about the first international organization that was created, that is still running even today. That is the United Nations. That is what we learned in our previous lesson about the United Nations. And we said it is an association, meaning it brings different countries to come together and associate with one another. So it is an association of independent states. Each state is independent of the other. Each state, each country has their own government, has their own political system. They have their own ideologies different from the other. So these countries or these states come together and associate with one another with the aim of maintaining international peace. You should never forget that. The main reason why countries or why the United Nations was created was to make sure or make every effort to see that there is maintenance of international or world peace, that there would be no conflicts, or if there are conflicts, that because they always exist, where there are human interactions, there will be conflicts, that these conflicts are able to be dealt with peacefully, and measures are put in place to make sure that there is peace. And we looked at how the United Nations was created, and we said, we mentioned that it was formed during a conference that was held in the USA in San Francisco, that is in June in 1945, and different countries came together. They formed a charter, which is a kind of an agreement, or that laid out rules or regulations that each and every member of that United Nations was supposed to follow. So when you talk of members, we are talking of individual countries. So countries belong to the United Nations as members. So Kenyans are represented in the United Nations as one country, the Kenyan country. So members are the different countries that have come together to form the United Nations. We also learned about the aims or the objectives of the United Nations as it was laid out in the charter that was signed or ratified by most of the countries. We said initially at the start only 50 members were in the United Nations, but as we are speaking, we have almost 193 countries that have ratified the UN Charter or the United Nations Charter, and they have become members of the United Nations. So in our today's lesson, we're going to have a subtopic which is the organization. So the subtopic that you're going to learn is the organization. The organization of the United Nations. So that is the subtopic that we are going to learn. So by the end of our lesson today, you should be able to mention, or you should be able to describe one arm of the United Nations. We are going to see how it has been organized. So in an effort to make sure that the UN has been able to achieve its mandate, and as we have mentioned, I'll continue to insist this, the biggest mandate of the United Nations is to make sure that there is peaceful interrelations or peaceful interactions between the countries, to make sure that the world peace has been maintained. That is the biggest aim, among other aims as we have already discussed. So to make sure that these aims of the United Nations or the objectives of the United Nations have been achieved, the UN crafted 6 organs. It crafted 6, or it put in place 6 organs. So it had different organs or arms to help make sure that the objectives or the aims of the United Nations have been reached. So the basic or the basic organ of the United Nations. So when you talk of an organ, is like a branch. For example, when you talk of a government, that is the most basic example that I can give. A government has different organs or arms or branches that help it govern the people. For example, in Kenya, the Kenyan government has 3 organs, right? That is the judiciary, the executive, and the legislature. So these are different arms of government. So the UN instituted 6 organs. It has 6 of them, 6 organs, to make sure that the mandate or the objectives of the UN have been achieved. So the first one is the General Assembly, which is like the basic one, or the most basic one. So we have number 1, the General Assembly. That is 1. Then we have the Security Council. The Security Council is the next arm. And then number 3, we have the International Court of Justice, which is normally abbreviated as ICJ, right? ICJ, International Court of Justice. And then number 4, we have the Economic and Social Council. The Economic and Social Council. And then number 5, we have the Trusteeship Council. And then number 6, we have the Secretariat. the Secretariat. So these are the different organs of the United Nations. So let me draw a chart to help you visualize how these organs are interrelated. So the most basic one, we have the General Council. The General Assembly, not Council. The General Assembly. So this is where all the countries of that belong to the UN come together. So the General Assembly brings together all the members. So all these other organs emanate or get their power from the General Assembly. The General Assembly brings together all the members, all the countries that are part of the United Nations. When they come together, they are known as the General Assembly. And we are going to be discussing more, each and every one of them. Then from that, we have now the different arms, or we have the different arms. We have talked of the Secretariat is one of them. We have the Secretariat. Then we have the ICJ, that is the International Criminal Court. Then we have International Court of Justice, and then we have the, which is the other one? We have the Economic and Social Council. Economic and the Social Council, and then we have the Trusteeship Council, and then lastly we have the Security Council. The Security Council. So you find all these organs are all related to, are all part of the United Nations. They work as under the United Nations, but each has its own duties. So each and every organ, as you have mentioned, the General Assembly, when all the countries come together, they come out with a specific agenda, or they have their duties when they come or meet together. The Secretariat, the International Criminal Court of Justice, we have the Security Council, we have the Trusteeship Council, and then we have the Economic and Social Council. And we are going to be discussing each and every one of them. What are their duties? Who are the members who are contained in that? So let us start by looking at the General Assembly as the first organ. The General Assembly. The General Assembly. Remember, it is the General Assembly of the United Nations. We are talking of the United Nations as an international organization. So the General Assembly, this is, as I have already mentioned, all members are contained in this organ. All members, each and every member who has ratified the UN Charter becomes an automatic member, or becomes a part of the General Assembly. So all these members or the countries meet once every year. They meet yearly. They meet yearly. They have yearly meetings. So you'll find these countries coming together once each and every year to discuss the different issues affecting the world peace, or that are involving the members of the world or countries, the world at large. So you find them coming together. So when they come together, that assembly is referred to as the plenary session. So they come together, they discuss the different issues, and we are going to look at what are the functions of the General Assembly. And then when there is an issue to be discussed, or for countries to make a decision is made by voting. A decision is made by voting. They vote, and a simple 2/3 majority is required. A simple 2/3 majority is required for a decision to be made by all the members. So if 2/3 of the membership of the General Assembly decides on an issue, they are that decision is taken to mean that every member, or it is supposed to affect all those members, or to affect the whole organization through the 2/3 majority. So each country is given one vote. Each country is given one vote. So whenever there is a decision to be made during the plenary session, the countries are given, each country is given one vote. But whenever they are meeting, you could send up to 5 representatives. For example, we could have 5 representatives coming from Kenya to go and represent Kenya in the General Assembly. But whenever there is an issue to be dealt with, or an issue that requires voting, Kenya will be given, or will vote as one nation. Yes, we have taken 5 representatives, but the vote that is counted is Kenya will vote as a member. So each and every country is allowed to have one vote. Then what languages? Remember, now we are talking of several countries coming together. Now, what language do they speak? So we have 6 official languages. 6 official languages that are identified, or that are accepted in the discussion. The first one is English. Then we have French. We also have the Spanish language. We have the Chinese, Russian, and Arabic languages. I've said there is English, there is French, there is Spanish, there is Chinese, there is Russian language, and then we have the Arabic language. So those are the official languages that are accepted in the United Nations. So if you speak any of those languages, then you can be able to address the plenary as you speak. You can speak in either Chinese, you can speak in Russia. In Russia, you can speak in English, or those. So now let us ask ourselves now. Let's take a step further and ask ourselves, what are the duties or functions of the General Assembly when all these countries come together and sit down in one plenary? What do they do? So the functions of the General Assembly. The functions of the General Assembly. Number 1, they discuss questions relating to international peace. They discuss questions relating to international peace. So if there is any problem, or there is any issue that is threatening the world peace or international peace, it is the duty of the General Assembly to come and discuss and interrogate these questions and find a way out. So whenever there is international, this is international, not internal, international international peace and security. So in case there is anything that is affecting or threatening the peace of the world, it is the duty of the General Assembly to discuss them. And then number 2, they admit new members. Any country desiring to join the United Nations, it is the duty of the General Assembly to admit them. They discuss on the eligibility of that member to become a member of the United Nations. Also, they dismiss members. So if you are a member of the United Nations and you are not following the charter or the regulations that have been accepted or the resolutions that have been passed by the United Nations through the General Assembly, it is the duty of the General Assembly to decide to remove you or to remove the membership of that particular country. And then it makes recommendations for peaceful settlements. So whenever there is a conflict between countries or there is issues affecting the world, they make recommendations on what actions to be taken. What are the remedies to the issues bringing turmoil or bringing problems that are affecting world security and peace? And then it also considers and approves. It considers and approves the budget of the UN. It considers and approves the budget of the UN. Remember, we said the United Nations is an organization. They require resources. They make a budget. This is the amount of money we wish to spend. They maintain peace through sanctions. So they can impose sanctions, economic sanctions against a certain country that is affecting or that has been an aggressor. For example, a country is inciting or is going against another country. So it is the duty of the General Assembly to give sanctions to that country to make sure that it has fallen in line. That is another duty. The next duty that we can note is that it makes recommendations within the scope of the United Nations Charter that affect powers and functions of the UN. So they change the powers. So if they want to increase the powers of the United Nations or they want to limit the powers of the United Nations, it is the duty of the General Assembly to amend or to bring a change to those powers. And then it elects, number 6, it elects non-permanent members of the Security Council. So as we are going to learn when we look at the Security Council, we have members, we have permanent members and non-permanent members. So it is the duty of the General Assembly to appoint the different members to serve as non-permanent members of the Security Council. We are going to learn more about that when we study the Security Council. And then they also number 7, they together with the Security Council, they elect the judges that serve in the International Court of Justice. So they work together with the Security Council to elect judges to the International Criminal Court of Justice. And then they initiate military action. They also initiate military action against aggressors. So in case one member has decided to take upon themselves and attack another country, it is the duty of the General Assembly to initiate or command military action. The other duty or the other function, they also investigate disputes. In case there is a dispute between members, it is the duty of the General Assembly to investigate these disputes and give a way forward. And then lastly, they facilitate the realization of human rights. They make sure that the human rights, which is the most essential part of the United Nations Charter, they make sure that the human rights have been observed and have been followed by each and every member. So today we have started looking at the organization of the United Nations, and we have said the United Nations has 6 organs or has 6 principal organs, led by the General Assembly, the Security Council, the International Court of Justice. We have the Economic and Social Council, the Trusteeship Council, and lastly the Secretariat. So as we end our lesson today, allow me to give you several questions that are going to help you revise for what we have learned today. So allow me to give you these questions. Revision questions from our today's lesson. So the first question is, name the organs of the UN. Name the organs of the UN. That is number 1. Number 2, which are the official languages used in the General Assembly. Then number 3, states the functions. State the functions of the General Assembly. So our revision questions today are, name the organs of the United Nations, that is 1. Which are the official languages used in the General Assembly? And then number 3, state the functions of the General Assembly. And I hope, learner, you have enjoyed and have an informative lesson.
Welcome to Manifested Publishers.
Hello learners, welcome to Manifested online classes. My name is Moniki. Before we start our today's lesson, I want us to review the previous lesson where I defined Boyle's law and did a simple illustration of Boyle's law. I said that Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. The volume of a given mass of a gas is inversely proportional to pressure at constant temperature. That is what we said. The example we gave was using a piston, or using this illustration. So I said that this is just a tube, and this is the piston. And remember in Form 1, we said there are three states of matter, which is a solid, liquid, and a gas. And again, he said that matter is anything which has mass and occupies space. So this space has matter, and we have the particles of air inside. So demonstrating Boyle's law using this simple demonstration, then I said that if you press the piston, the volume will decrease. The volume decreases. And at the same time, the pressure increases because the particles, they're now closer to one another, and hence they collide more effectively, or is more effectively within themselves and with the walls of the container. And that collision is what is creating pressure. That is a simple demonstration I give you in the previous lesson. And I say that you can present this Boyle's law in a curve, or using a curve, or a curve to demonstrate Boyle's law. I drew a curve like this. I told you that this is a graph of pressure against volume. So graph of pressure against volume said that anytime they are inversely proportional, that when pressure increases, volume decreases, and when volume decreases, pressure increases. Therefore, the curve was like this. And one thing I want you to note is that the curve does not touch both the x and the y axis. And the reason is that the volume cannot be zero and the pressure cannot be zero again. And that's why the axis, or this curve, is not touching the y-axis and the x-axis, because the volume cannot be zero and the pressure again cannot be zero. If you have a volume, then there is pressure involved in that volume. So basically that is what we discussed in the previous lesson. In this lesson, I want to show you the mathematical expression of Boyle's law. The mathematical expression of Boyle's law. In Boyle's law, we said that volume is inversely proportional to pressure. So this is when volume increases, pressure decreases. And when pressure increases, volume decreases. Therefore, volume, say, is inversely proportional to pressure. This is a symbol of proportionality, that volume is inversely proportional to pressure. This is just 1 over pressure. which can also be written as V standing for volume is inversely proportional to pressure. So V inversely proportional to pressure. And this one can also be written as V is equals to a constant 1 over P. V is equals to a constant over 1 K 1 over P. This one can now be expressed as Vp is equals to a constant. So if you multiply V and P, then you'll get this constant. So Vp is equals to constant K. Therefore, if you have a certain amount of a gas, a certain volume of a gas, if this volume of a gas is having some pressure because these particles of a gas are in continuous state of motion, so they are colliding with one another and also with the walls of the container or the vessel where this gas is. Remember again, you have seen that the volume cannot be zero and the pressure again cannot be zero in this graphical representation. Therefore, if you have a certain volume of a gas, this volume of a gas is having a pressure. So if that volume changes, let's say you have volume, you have V, volume 1 of a certain gas, and pressure 1. If the volume changes to pressure, if the volume changes to V2, if volume changes to V2, the pressure also changes to P2, because anytime you interfere with the volume, pressure is also interfered with. If you raise the volume, pressure decreases. I hope you get that. If you lower the volume, pressure rises or increases. Get that very clearly. So this means that, or this one can be expressed as V1 P1 is equals to P2 is equals to V2 P2, which is equals to K which is a constant. Therefore, V1 P1 is equals to V2 P2. And that is the expression we use in Boyle's law. And this expression just means that V1, or where V1 is equals to the initial volume V1 is the initial volume just before the change. V2 is the final volume. P1, the initial volume. P2 is the final pressure. So this is supposed to be initial pressure. Initial pressure. So V1 is the initial volume before you did a change. V2 is now that final volume, P1 is initial pressure, and P2 is the final pressure after the change. Therefore, this is the expression we'll be using in all our calculations. In all our calculations, we'll use V1 P1, which is equals to V2 P2, where V1 is the initial volume, V2 is the final volume, P1 is the initial pressure, and P2 is the final pressure. So that is the expression. So basically that is how you are coming up with this expression, and that is our lesson. But just before the end of the lesson, I would like to remind you or do a small recap on what we have learned. We have learned that Boyle's law states that the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. And today we are doing the mathematical expression of Boyle's law. So you have seen that volume is inversely proportional to pressure. So this volume V is inversely, I've seen this as a symbol of proportionality, inversely proportional to pressure, which can also be written as V is equals to a constant 1 over P. So if you multiply this P and V, you now get Vp, which is equals to this constant. And that's why you're getting this expression. And again, I've said that if you have a certain mass of a gas, with a certain volume, because a certain mass of a gas will have a certain volume. If you change the volume of that gas, you either raise it or you lower it, the pressure will also change. And that's why I've said that if you have volume V1 at pressure P1, if the volume changes to V2, the pressure also changes to P2, because anytime you raise or lower the volume, the pressure will also rise or go down at the same time. And that is now where we have come up with this expression that V1 P1 is equals to V2 P2, which is equals to a constant. And therefore, we have said that V1 P1 is equals to V2 P2, where V1 is the initial volume, V2 is the final volume, P1 is the initial pressure, and P2 is the final pressure. Get that very clearly. That is the end of our lesson. But before I end, I will give you these assignments. Assignment. Assignment is derive a Boyle's law formula. Derive a Boyle's law formula. We have looked at how you're able to derive the Boyle's law formula. I believe you'll be able to derive the Boyle's law. That brings us to the end of our lesson. Thank you for being attentive. Bye. Meet in the next lesson.
Welcome to Manifested Publishers.
Welcome to History and Government lesson. Today we are going to study on a topic entitled Establishment of Colonial Rule in Kenya. Establishment of Colonial Rule in Kenya. That is the topic that we are continuing to study. And remember, we started by looking back and seeing how the British, or the process of the partitioning of East Africa, and finally how the British started to occupy the African or the Kenyan territory. We also learned that they used company rule to establish their rule, which company was used by the British to establish their authority and control in Kenya. I hope you are able to remember. We said it is the Imperial British East African Company. And we studied how it established the control, how it started getting areas and investing in the Kenyan territory. But at some point, it was overwhelmed. The duty became too much because the land was quite big and they did not have enough resources. So the government of Britain, or the British government, decided to send in more officials to act directly on behalf of the British government. And that is how they ended up establishing and occupying the Kenyan territory. So in the last lesson, we learned how the Kenyans reacted, how the Kenyan societies reacted to the occupation of the British, the response of the Kenyan communities to British occupation. And we said the societies reacted in 3 ways. Can you be able to remember the 3 ways in which the Kenyan societies were able to react against the colonial or the British people? The 3 ways. We said there are 3 of them. 3 ways. Which are they? The first one, we said it is resistance. Resistance. They resisted. They stood and fought against the British. And we mentioned several communities. We also mentioned that they reacted by collaborating, that is, cooperating with the British people. And then we said there are other communities that had mixed reactions. Mixed reactions means some were resisting while others were cooperating at the same time. And in our last lesson, we started engaging into the resistance as a response. So number 1, we are studying resistance to British rule. That is the subtopic that we are having. And the community that we are studying is the resistance of the Nandi. So number 1, the first community is the Nandi. We said there are other communities apart from Nandi that resisted. Are you able to remember them? The communities that resisted the British colonial rule. The first one that we are studying are the Nandi. We also mentioned there are the Bukusu. We also shall see the Agiriama, and then finally we shall look at the Somali. So, but we have started with the Nandi, and we said in our last lesson we studied the causes. What were the things that forced the Nandi to resist against the British rule? We said there are several reasons. The major one being the pride of the Nandi. They thought they are superior. They had conquered most of their neighbors, so they had a sense of pride. They were naturally people who were warlike, so they were able to defeat most of the neighbors. Also, they had a very strong leadership that galvanized the people and encouraged them to fight against the British. Then the other reason is that they did not like the color. The color of the British made them to fight against them. They were considered to be like devils. Also, Kim Nyole's prophecy played another role, or was another cause of the people of the Nandi fighting against the British. He also mentioned that the land alienation, or the loss of land, was a cause for them to fight. Also, they had a military They had military training. Most of their army was military, was well trained and disciplined, which encouraged them to fight against the British, among many other causes that we mentioned. So in our today's lesson, we are going now to look further and make another step forward and ask ourselves, how did the war progress? How did they resist against the British? How did the war begin, and how were they defeated, if at all they were defeated? So we're going to look at the cause of the Nandi resistance. The cause of the Nandi resistance. The cause of the Nandi resistance. And the first thing we are supposed we learn is that it started in 1895. That is when the resistance started, and it started after certain British known as Andrew Dick attacked and killed two Nandi warriors. Who had strayed into his camp. This was a British trader. So in his camp, he met some two Nandi warriors who are working in his camp, and decided to kill them. So actually this is to kill. Decided to kill two Nandi warriors. So when he attacked and killed these warriors, this angered the whole community. The whole community now, or the other people, decided to retaliate against the British, and they in turn killed the Nandi. The Nandi killed another British trader who was known as Peter West. Peter West. So immediately after Andrew Dick attacked and killed the two Nandi warriors, the community retaliated by killing another trader who was known as Peter West. So that sparked the bad blood, or sparked the killings, or the resistance of the Nandi. Immediately after that, the Nandi also continued with a series of attacks on the British traders. So there was a series of attacks. They constantly attacked the British traders who are coming from the coast as they go towards Uganda, that was engaging in the trade. So every now and then the Nandi could stage or mount attacks against these traders, and it happened that each and every time they attacked, the British could send expeditions, that is an army or a people, to try and quench or fight against the people. So this happened by them. So the British, we are saying, decided, British sends expeditions, and these are organized armies to go and try and fight against the Nandi, who every now and then are attacking the traders on their trading activities. But something to the detriment of the British, every time they send an expedition, it was unable to conquer the Nandi, because the Nandi were well trained. Remember, I said they had a very strong army based on the initiation. Each and every time the young men were initiated, they were called into the army, to serve into the army, and they became very disciplined. So every time the British was able to send an expedition after an attack, it was always defeated. So these continued that in 1897, that is 2 years later, in 1897, that is 2 years later, the Nandi made a very severe attack on the British Mail Party. British Mail Party. This was a group of traders that were going on with their trading activities, but the Nandi decided to fight, or decided to attack them, and this really angered the British. So they decided to bring a very or even more punitive expeditions to fight against the Nandi. But in the same way, the first one had started or had been unable to be quenched. The British were defeated. Why? Because immediately the British were bringing their armies or their soldiers to fight against the Nandi. The Nandi could just attack them and then go and hide in the terrain, hide in the forest. And remember, this is their homeland. They understand their terrain better than the British. So they could easily attack and then go and hide against the British. So the British could not make significant impact. They could not attack or be able to defeat the Nandi warriors, and because they could easily sleep, they have just attacked them, and when they ran away, you could not know where the British could not know what had happened. This happened even continued even in 1899 when there was building. This happened. There was when the building of the railway reached the Nandi territory. The attacks by the Nandi intensified at this period. Remember, in the Kimyole's prophecy, as I had mentioned earlier, he had seen the prophet had seen an iron snake. He had seen a very big snake coming into the land of the Nandi. So when the Nandi saw the railway entering their territory, they saw what had been prophesied earlier by Kimyole, and these made them even more furious because they had discredited Kimyole as being a witch, or being his prophecy not being true. But now they saw it coming. They saw the rail entering their land. So they intensified their fight. They now could fight even more because they did not want that rail to pass through their territory. Remember, we said the Nandi are they were very proud. They had prestige. They believed they are the best, and they had the right to own that land, and nobody else could be able to do anything on that land without their consent. So they intensified their fights during this year. And so the British tried to get the Indians and the Swahilis and the Maasai together with some of the Buganda auxiliaries. Those are people that were hired to come and fight on behalf of the British. So the British tried to organize a very large expeditions, especially during this time when they are building the railway. Remember, the railway is the center stone. It could have eased the movement of raw materials. So they really needed this railway to go to those interior parts. So they tried to bring other people, and I have mentioned they tried to bring the the Swahili soldiers, and also hired the Baganda together with the Maasai auxiliaries. These are hired hands to come and fight. But even so, they still were unable. They were still unable to get, or they were still unable to continue or to be able to fight effectively or stop the Nandi from attacking them. So they became frustrated. But the British government at that time sent a colonel or or an army commander who is known as Colonel Menes quite a name here. Colonel Menes Gen, right? This was a colonel that was sent, or that was leading the expeditions that was sent. Actually, this was in 1900. So when this man came, he discovered that the reason why the Nandi are fighting so furiously, and they have been, every expedition that they have tried to bring against the Nandi was being quenched or was being defeated. He discovered that the strength, or the strength of the Nandi was based on the Orkoyot, who was the religious leader, who was the overall leader of the Nandi. So he was the chief strategist of the Nandi community. He was the source of the strength of the Nandi. So when he discovered the Okoryot at that time, who was known as Koitalel Arap Samoei, right? And Arap means the son of, right? So the Orkoyot at that time, Koitalel Arap Samoei, this is an I, Samoei. So this man discovered that Koitalel Arap Samoei, who was the leader of the Nandi people at that time, was the reason why the Nandi were so united, was the reason why the Nandi could not be defeated, because he was the chief strategist. Remember, he was the religious leaders. So he made or brought all the people of the Nandi together. So what this man did, he decided to trick the Koitalel Arap Samoei with the other leaders into a meeting in the pretense of trying to discuss out or getting a way out. But what he had in intention was to execute, and actually he executed Koitalel Arap Samoei along with some other leaders. So these demoralized. It demoralized the warriors who are fighting, because now the leader, or the strength, the centerpiece, the cornerstone of their resistance has been captured and executed. And that was the strategy of this colonel. So he discovered that the community was galvanized, or was united by the institution of the Orkoyot, and the leader then, who was taking the Orkoyot at that time, was Koitalel Arap Samoei. So he tricked him together with some leaders into a peace meeting, and then he captured Koitalel Arap Samoei and executed him. So that really demoralized the warriors. They could not now have a united attack against the British. They had now been disheartened. Their hearts were broken because their leader, the one who was leading them, the one who was giving them the courage to go and fight, had now been executed. So the British took that opportunity, and in 1905, immediately after the execution of the Koitalel Arap Samoei, the Okoyot at that time, though they continued to fight, but they did not fight with the vigor that had. So in 1905, the British sent the biggest expedition ever they had ever amassed. They were able to get 1,500. They were able to get 1,500 Indian and Swahili soldiers to come and fight against the Nandi. Also, they also included some Somali soldiers, right? And then, apart from the 1,500 soldiers that were sent at that time, they also hired 1,300 auxiliaries to come and also join in the expeditions. Apart from that, they also armed. They had 900 armed porters. These were the people who were carrying the trading items from the interior into the coast, the porters. So they armed them, and also they had 10 machine guns. 10 machine guns and 2 armored trains. Armored trains. So this was the biggest expedition that the British had amassed at, against any community, because now the Nandi had become too much. So the British decided to get the largest army, the largest expedition that they could get. So you can imagine all these people are directed against one community, against the Nandi, who have been fighting for them actually for a very long time. So though the Nandi at this time, they are demoralized. Remember that they are now demoralized because their leader has been executed, and now the leaders and the leaders are unable to continue. The ones who are available at that time could not effectively take the opposition of the Orkoiyot. So the Nandi, though they tried to fight bravely, they were defeated in this year. And they were finally taken over. Their land was finally taken over by the British. So the Nandi is one community in Kenya that gave out a very long resistance. They resisted the British for quite a long time. They put up a fight that the British did not expect. It was you can see it started in 1895 and actually ended in 1905. That is 10 years of continued fighting. That was very expensive for the British, but for them, they were in their land because they had understood their land. So you ask yourself, what enabled the British or the Nandi to give such a long resistance? So reasons for the long resistance. Number one, they understood their terrain. So that is one reason why they put on a very long resistance. Reasons for long resistance. So number one, I've said the terrain worked to their advantage. The terrain. So the mountainous terrain, this is a highland, this is the Rift Valley. They have hills, they have valleys. So they understood their terrain very well, as opposed to the British, who were visitors in that area, and even the Swahili and the Swahili and the Somali and the Indians who were coming to help the British could not be able to understand that terrain. So that gave them an advantage. Another reason why they put on a long resistance was their army. They had a very large army that was provided by the age-set system. Every time they had initiation, they recruited new army members, and the army was very disciplined, just like that of the British. They were very disciplined and well trained because they took a lot of time, and also they had a constant supply of food. Constant supply of food. They had constant supply of food. They had mixed economy. They were farmers and livestock keepers. Though with the British coming to attack them, at some point they used the scorched earth policy, where they could burn down and destroy the Nandi food. They had surplus food because they were livestock keepers. So that enabled them to continue fighting. And also they had experience. They had military experience. They had military experience that enabled them to continue fighting. They had fought a lot of battles. They had subdued all their neighbors, including the Maasai that came to help the British. So they had amassed a lot of experience in their fighting. The next thing was that they had pride. They did not believe that they could be defeated, and it was their culture to continue to get wins in every battle. So they were a very proud people. They were a people who were susceptible to war. They could not accept any kind of defeat. And then the second last, they had able leadership. Able leadership. Koitalel Arap Samoei, who was the Orkoiyot at that time, provided a very solid leadership. He galvanized the whole community. The warriors, together with the communities, came together to fight against the British. And then lastly, the climate was to their advantage. The cold climate, the British could not withstand the climate in the Rift Valley. So that gave the Nandi a comparative advantage over the British. So today we have learned about the cause of the resistance of the Nandi, and how we have interrogated into details how they fought against the British and how finally they were defeated in 1905. And I've also explained the different reasons why the Nandi were able to give such a prolonged period of fighting. They fought for a very long time. So that brings us now to the end of our lesson. But before we end, allow me to give you this revision question. Allow me to give you this revision question. You just write it here. Revision question. And the question is, state and explain the reasons why the Nandi put up a prolonged resistance. State and explain the reasons why the Nandi put up a prolonged resistance. State and explain the reasons why the Nandi put up a prolonged resistance. So those that is the question I want you to attempt at your free time. I encourage you not to check on what you have or on your notes that you have made. Just try and remember what we have learned. And with that, we've come to the end of our lesson today. Until the next time we shall meet, it's bye-bye.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we continue with our topic of discussion, and this is genetics. Today I would like us to discuss the causes of variation. During the last lesson, we discussed the two types of variations, that is continuous and discontinuous variations, and we gave examples. And from that, we want to find out what are the causes of those variations. Now, the first thing to note about variations is that variations can either be caused by genetic factors or environmental factors. The genetic factors are factors within us. For example, our gametes and so on and so forth, how fertilization occurs. But also these variations can also be brought about by occurrences that are taking place in the environment, that is outside our bodies. And we shall mention something that is called mutation. So basically we can say that variations are caused by both genetic and environmental factors. And these factors include, or the causes of variations include, one, the process of gamete formation. The process of gamete formation. When gametes are being formed, there is likelihood of variations occurring there. And this is why we earlier mentioned that even if two brothers are from the same parents, they do not look exactly the same. They do not look identical, because the process of gamete formation is different between the two. As we shall see. Now, in the process of gamete formation, I would like us to mention two processes. One that is called crossing over. That's one of the processes during gamete formation that brings about variation. And this crossing over, this is the exchange of genetic material between chromosomes, which takes place at prophase 1. Prophase 1 is the prophase of meiosis 1. We discussed the cell division at form 3 level. So we know the happenings that occur during this stage that we are referring to as prophase 1, whereby we say that the homologous chromosomes, they come together, they intertwine, and then an exchange of genetic material can occur there. So we are going to have an illustration of that. For example, I have a chromosome here. Of course, you know that the chromosomes are made of two parallel strands that we call chromatids. And those chromatids are joined together at the centromere, that is the center. And then I have another chromosome as well. Let's say we shade one so that we can be able to distinguish them. Although when we are drawing diagrams in biology, we are not supposed to shade, but I'm just using this to show the distinction that this chromosome is different from the other chromosome. So these chromosomes, when they come together and intertwine, we refer to this as synapses. Synapses, which is the intertwining of chromosomes. They intertwine at the point of intertwining at the chiasmata. This point is what we are referring to as chiasma. This is another chiasma. So when there are two, they are called chiasmata. Chiasma is the singular. They intertwine. First of all, they move close to each other, then they intertwine at the chiasma. And whatever is formed, forming bivalents. So for example, the whole of this structure is a bivalent. so forming bivalence. So after intertwining, an exchange of genetic material will take place. An exchange of genetic material will take place such that when they break apart, when they reach the point whereby they'll separate, so we can now remove the chiasma. They have broken apart. So there is this section that was in this chromosome that has been transferred to this other chromosome. And there is this section that was in this chromosome that has been transferred to the other chromosome. So that is the point that leads to the exchange of the genetic material. So the genes that were in that particular section have been exchanged. They have been transferred from this chromosome to this, and some have been transferred from this chromosome to the other. So we are calling that crossing over. And it's one of the causes of variation during gamete formation. So we are saying that it is the exchange of genetic material between chromosomes which take place at prophase 1. So this process occurs at prophase 1. Another area where the another stage in gamete formation where the variations can occur is what we call the independent assortment, which occurs during metaphase 1. Now, independent assortment simply means the random assortment. This is whereby the next stage after this, after prophase 1, the chromosomes will move on to metaphase 1, whereby they will be aligned at the equator of the spindle fibers. So the alignment of the chromosomes, while still as bivalents, at the equator of the spindle is random. So they can be aligned in a particular manner, or they can be aligned in a different manner. So there are various ways in which those chromosomes can be randomly aligned at the equator of the spindle. So we are saying that the alignment of chromosomes, that is homologous chromosomes, while still as bivalents, is random. And that is what we are calling independent assortment. We'll illustrate that. So it's random, and then after that random assortment, after they start now separating, they can separate in different manners. So for example, that one can go to that daughter cell, this one can go to that particular daughter cell, this one can go to this daughter cell, this one can go to that daughter cell. So there are different ways in which they can lead to different daughter cells where they'll become gametes. Of course, transferring some variations to that gamete, and on the other side transferring some gametes. So we'll have an illustration. For example, we have this is a chromosome, and assuming its pair is this, a smaller one, So that is one way in which the chromosomes can be assorted. So this one can go to one daughter cell, and this pair can also go to the other daughter cell. So this is one way in which random assortment can happen. On the other hand, you may have these and these going together. And these ones go to a particular daughter cell, while the ones I'm using a smaller size. And these ones can go to a particular daughter cell. So this shows the first situation and the second situation. So this shows a random assortment of homologous chromosomes. So there are so many ways in which the chromosomes can be assorted in different ways, leading to very many variations. So this one can go to one daughter cell, this one goes to another daughter cell, carrying its own genes there. On the other hand, still within the same process of gamete formation, these ones can go together and these ones can go together, carrying different genes into a certain daughter cell. So that random assortment, or that independent assortment that occurs during metaphase 1 is what we are saying that is another cause of variation during the process of gamete formation. So gamete formation is one process that leads to variations, either during crossing over or during independent assortment. But just to elaborate that point on independent assortment, for example, in humans, we have 23 pairs of chromosomes. That means 46 chromosomes in every somatic cell. So in this case, what can happen, if we have 23 pairs of chromosomes, then it means the number of independent assortments possible is 2, because we have paired chromosomes, raised to power 23. Those are the number of times we can have different assortments in our chromosomes during metaphase 1, because we are saying that in humans we have 23 pairs. So 23 becomes the power. The 2 for the pair can have 23 to the power of 23, as in the number of times it can be assorted. So if you calculate this value, you will get something that is above 8 millions number of ways in which this can happen. In fact, if you are to get a calculator and say 2 raised to power 23, then it's going to give you a figure that is above 8 million, the number of times we can have different assortments out of the 23 pairs that we have. So that is one likelihood of variations. Number 2, variations occur during fertilization, and this is whereby the male gamete nucleus fuses with the female gamete nucleus to form a zygote. So in other words, we are saying that the zygote will carry the genes that were on the male gamete nucleus and those that are in the female gamete nucleus in different combinations. So basically we are saying that the gamete that fertilized the first time may not be identical to the one that will fertilize the second time. So, and this one we are saying that even the siblings who are of the same parents, they do not show complete identity, or they are not completely identical because of fertilization. Also, there is another cause of variation, and this one is basically environmental, and this is now during mutations. And you can see that mutations, these ones are spontaneous, or you can say that they are inheritable. They are inheritable changes in genetic constitution of an organism. The inheritable changes in genetic constitution of an organism, and these mutations are caused by mutagens. Mutagens are the ones that cause mutations, and we have examples of mutagens, e.g. We have things like radiations, such as the UV, ultraviolet rays. They have been associated to be some of the radiations that cause the genetic constitution of an organism to change. And when the genetic constitution changes, then it is transferred to the offspring, especially those mutations that affect the gametes. You can say that mutations that affect gametes are inheritable. They are inheritable because gametes can be they are transmitted from parents to the offspring. So the most significant mutations are those that happen in the gametes because they are passed on. So if there are changes that happen, then that is likely. So we are saying that mutagens include radiations, even gamma radiations, gamma rays. We even have chemicals, chemical mutagens, all these that cause mutations. E.g., we have what we call the mustard gas. So all these colchicine. So those are some of the chemicals that may cause the inheritable changes in genetic constitution, what we are calling mutations to happen. So we are going to stop there and have an assignment. So the assignment, explain how the following processes lead to variations. A, crossing over. B, independent assortment of chromosomes. And C, mutations. So we are going to stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Hello and welcome to our today's lesson, History and Government. We are learning about the establishment of colonial rule in Kenya. That is the topic that we are learning, and we are been learning about the Kenyan society's response to the process of colonization by the British. And just as a matter of remembrance and overview of what you have already covered, is that we mentioned that the European or the Kenyan communities reacted in different ways towards the invasion by the British in their territories. What are these ways? Which are these responses that the Kenyan communities instituted against or towards the British? Are you able to remember them? We said there are three ways in which, or there are three responses that the Kenyan communities responded to the process of European colonization in Kenya. What are these three ways? We said number one, they resisted. There was resistance. They came up in arms against the British occupying their land. Some of the communities that resisted include what? The one that we are studying, that is the Nandi. Which are the other communities that resisted? We mentioned that in our introductory lesson. We said the other one is the Agriama. We also mentioned the Bukusu and the Somali. Apart from resistance, which was the other method? We said number one, we have resistance. Number two, which is the other response that the Kenyans gave towards the British. The other one was collaboration. Very good. They collaborated or cooperated or accepted the rule in exchange of protection and other things. And there are two communities that collaborated with the British in Kenya. That is the Maasai and the Wanga, that is in among the Western Bantus. Also, there was a third response which we classified or which we called the mixed reaction or mixed response. That is, portion of the community was collaborating with the British while the other was resisting, or initially they collaborated and later on decided to resist. An example are the Agikuyu. So those are the responses, and that is what we are tackling. But now in our today's lesson, and under the Nandi resistance, in our previous lesson we looked at the factors or the reasons why the Nandi resisted the British rule, and we mentioned and discussed them in detail. And then in our last lesson we also discussed the cause, how they fought, what initiated the war, how they fought against the British, and the expeditions that were sent by the British against the Nandi. And we also outlined and discussed the reasons the factors that made the Nandi to put up a prolonged resistance. Remember, we said they started their resistance in 1895, and that resistance lasted up to 1905 when they were finally defeated by the British. So we mentioned the reasons why they put up such a prolonged resistance. Are you able to remember the reasons why they resisted for quite a long time? The reasons included the terrain that they were living in. The mountainous terrain was well known to the Nandi warriors, but the British, who had come with their weapons that needed to be moved around, could not adapt to that terrain. So the terrain encouraged them to use guerrilla warfare. They could attack, then go and hide in the mountains and the hills, so the British could not advance against them. Apart from that, they had a sense of pride. They were not easily going to give up to foreigners coming to take up their land. Apart from that, they had a very strong and able leadership that was provided by the institution of the Orkoiyot. And the Orkoiyot at that time was Koitalel Arap Samoei. Should remember that. So this man provided direction. He organized the army. He organized the community to fight against the British. Which other factors enabled or led to the Nandi putting up a very strong resistance or a prolonged resistance for quite some while. The other one was military experience. They were able, or they had been involved in other kinds of war with their neighbors. So these enabled them to continue fighting, and they had amassed a lot of experience. Their warriors were experienced to fight because that was a norm to them. They could raid their neighbors at will. They could raid the Gusi, they could raid the Luo, they could raid the Nandi, the Maasai, because they were quite a strong people, and they were well trained. Apart from that, they had a very large army, a very large supply of army, that each and every time they were men who were ready to fight on behalf of the community. Also, they had a steady supply of food, such that even when the British employed the strategy of scorched earth policy, that is the burning down of the crops of the Nandi and killing some of the animals, because of the vast nature of the livelihood or the economic strength of the Nandi, they were able to have a steady supply of food. So their warriors were well fed and they were strong. And then finally, we also discussed the impact of the climate on the British. They could not be able to sustain, or they could not be able to fight effectively, because the climate in the highlands was quite cold, and they could not be able to resist the diseases, the tropical diseases that attacked them. So those are some of the reasons why the Nandi were able to give such a prolonged resistance. So in our today's lesson, we are going forward to learn what are the factors or the reasons that led to them being defeated. The factors that led to them being defeated, that is one. And then number two, the results of their resistance against the British. So allow me to start with the first part, which is reasons, or you can refer to that as factors for their defeat. And when you talk of their defeat, let me write the Nandi, right? The Nandi defeat. Why were they defeated? The factors that contributed to them being defeated. The first one is that some African communities supported the British. An example are the Maasai that were conscripted by the British, and they helped the British to fight against the Nandi. Remember, the Maasai were traditional rivals of the Nandi. The Nandi constantly raided the Maasai community. So with that hatred, the Maasai joined up together with the British to fight against the Nandi. So that contributed to the Nandi being defeated. Actually, this happened in 1905. You should not forget that. So apart from the Maasai, we also had the Somali. That also took part in helping the British to fight against the Nandi. Even as such, other communities around the Nandi did not come to support the Nandi to fight against the British. An example is the Luya community. It did not come to aid or support the Nandi as they fought against the British. That is the first reason. Some African communities supported the British, while other communities, did not come to support the Nandi. So you can imagine, if other communities could join in arms together with the Nandi, they could have easily defeated the British. But now, because that was not the case, that brought them to, it resulted to them being defeated. Then the other reason, or the other factor, was the British had superior The British had superior weapons. The British had superior weapons. The Africans or the Nandi were using rudimentary arms. They used arrows, they used daggers, they were using spears, as opposed to the British who are having rifles and machine guns. The Nandi were using spears, they were using arrows. So they did not, they are comparing between a spear and a gun or a machine gun. Which one is likely to outdo the other? That is why the Nandi ultimately were defeated, because the armies or the British army had superior weapons compared to those of the Africans. The Africans had not amassed the technology of creating guns. Remember, even as we are talking during this period, there were no industries of producing arms in the Kenyan territory. So that made a contribution towards the Nandi being defeated by the British. Apart from the superior weapons that they had, there were natural calamities. There were natural calamities. There were natural calamities that influenced or made them to be defeated. An example is the rinderpest. The rinderpest is the rinderpest that attacked their animals and led to most of the animals dying, thus making them to lack food. So when they were attacked by this pest, they were unable to sustain their economy. They were also attacked by smallpox. Smallpox. This is a disease that they did not have initially. So when they were attacked by this disease, it weakened most of them, and most of the warriors were affected. They could not effectively fight. So the natural calamities that came, this is not a result of the British. It was just a natural occurrence that really affected them, and it interfered with their way of fighting or with their way of going against the British. Let us take a step further and look what are the other factors. Number 4, the next factor, number 4, is the British used the scorched. The British used the scorched earth policy. This is where, or this involves the British going to, or after they have attacked the Nandi at one place, they could come down and burn down. They could burn and destroy the crops and the animals that had been left by the Nandi while they were running away. Remember, the Nandi were using the guerrilla warfare. They would come and attack the British and then run away from their homes to go and hide in the mountains, to go and hide in the forest. So these, they left their homes unattended to. So when the British came together with their collaborators, they would burn down their crops, they would destroy their silos, they would destroy their granaries. So when the Nandi came back, they were unable to get food. So the scorched earth policy to some extent also contributed to weakening the defense or the resistance by the Nandi, and ultimately they were defeated. And then lastly, or the last factor that made them to be defeated was the death of Koitalel Arap Samoei. The death of Koitalel Arap Samoei. So this was the leader or the Orkoiyot. He was the Orkoiyot at that time. And remember, the Orkoiyot was a very essential person in the Nandi community. He was the overall leader. He was. It was the institution that brought together the members of the Nandi community. So they are Orkoiyot, who was at that time known as Koitalel Arap Samoei, was tricked by the colonel of the British and was captured and eventually killed. So that demoralized. It demoralized the warriors. It demoralized the warriors. So the warriors could not mount up an effective attack against the British as they had done under Koitalel, because Koitalel was the spiritual leader and he also led the community in its wars or in its expeditions against the enemies. So these weakened, or it made them to lack direction. The leaders who took over control after the death of Koitalel Arap Samoei could also not match up the organizational skills of Koitalel Arap Samoei. So the death of Koitalel Arap Samoei was, we could conclude that was the final nail to the coffin of the resistance of the Nandi, because they were now unable to effectively fight against the Nandi. So these are some of the reasons that contributed to them being ultimately defeated. And as we mentioned in our last lesson, they were defeated in the year 1905. So now that they have put up a fight, they have fought against the British and they have finally been defeated. What were the consequences? What were the results of their resistance? So let us take a step further and look at the results. The results of the Nandi resistance. The results of the Nandi resistance. What were the consequences? What were the outcomes of their resistance against the British? Number one, loss of life. Most of the warriors lost their lives as they resisted the British. Remember, the British are using superior weapons, the machine guns and the rifles, the repeater rifles. So these led to most of them losing their lives. It is estimated that thousands of around 1,000 of warriors lost their lives during that period of their resistance. There was a lot of loss of life. Most of their lives were lost during the resistance. And then number two, they lost their land. Loss of land. So the fertile land, the land that was very fertile, that was producing the food they were using, was now taken over by the British. So they lost their land to the British ultimately, because now they have been defeated. They cannot continue to occupy that land. So the British came and took over the land. And while they were taken, or their land was taken up, the Nandi were pushed into reserves. The Nandi were pushed into reserves. Most of them, because now their fertile land has been taken away for the British settlers. The Nandi were now forced to move into the less productive land. And others were even left to become squatters in the land that the British were living in. So that was another consequence. The fourth one is that they lost their prestige. They lost their influence or prestige. They lost their influence. Remember, the Nandi were the expendables in that area at that time. They believed they could not be defeated, but now that the British have come and have finally defeated them, they now lost their influence in the region. They could now not be feared the same way they had been feared before. Let us look at some other reasons or some other results of the Nandi resistance. So the fifth one, most of the Nandi warriors were conscripted into British service. Now, because of their military skills and their ruthlessness, the British conscripted or forced the Nandi warriors to work as policemen, and also to join into the army. So they were now able to work under the British government, and also they lost their independence. They lost their independence. They lost their independence, and then lastly, they were displaced. They were displaced from their original areas of occupation. So, as the British advanced and took over their land, the British or the Nandi people were displaced into other areas. Some of them had to move away from their home. So those are some of the results or the consequences of the Nandi resistance against the British. And now I would give you a revision question as we end our lesson. Remember, we have been discussing the reasons why the Nandi resistance was defeated and the results of their resistance. So, revision questions. I'm going to give you 2 questions. And the first question is, discuss the reasons why the Nandi resistance was subdued. And then number 2, explain the consequences of the Nandi resistance against the British. Number 1, discuss the reasons why the Nandi resistance was subdued. And number 2, explain the consequences of the Nandi resistance against the British. And I'm sure those are the very easy questions that we have effectively tackled in our today's lesson. Thank you for having time to study with me. Until the next time we shall meet for a history and government lesson. Bye bye.
Welcome to Manifested Publishers.
Hello learners, welcome to chemistry lesson. My name is Mwaniki. We are learning chemistry and the topic is gas laws. Remember, the forum is still Manifested online classes. In our previous lesson, we derived the formula for Boyle's law, where we said that V1 P1 is equals to V2 P2. And we said that V1 is the initial volume, P1 is the initial pressure, V2 is the final volume, and P2 is the final pressure. That is the formula we will be using to do some calculations involving Boyle's law. In this lesson, we are going to discuss the units of pressure. We want to discuss some of the units you can use to measure